binary logistic, because basically in this 5-day session, we'll see, we will build these concepts one by one. So today we are keeping it a little simple, and many few of the advanced functions probably we will touch towards the end, because if like for most many of us are new to this, so we don't want to make it heavy on day one. But of course, the people who have been doing the statistical analysis, and if you people want to ask some question or wants to add something, you are most welcome to do that. So let's begin this session with one very simple example. So initially we have used the taxi fare and the kilometer, but now we have changed the example, and this is the example. Like, you can see the number of hospital days of hospital stay and the age. So if I want to predict the length of hospital stay, which I am measuring in days, and the patient age and various other factor. So here you can see there are two columns. So on column one, it is the age of the patient, and in column two, it is the length of hospital stay, which is in days. So, can you make a simple formula to predict the length of hospital stay based on age? Like, you can see, if the age is 20, the length of hospital stay is 4. If it is 10, then it is 3. So, probably if you use this one, like 10 and 3, you can make a simple formula. How some of you can try, and by which, like, we used to make many time, you see that especially in pediatric population, whenever we have to predict the weight of the baby, we use age to predict the weight, like age into 2 plus 8 or something like that, to predict the weight. So that has come from the linear regression, but that is again a prediction formula. Similarly, seeing these two variable, it is related with some formula, and that's the prediction. Prediction means using the same data. If I want to tell the length of hospital stay based on age, whether I will be able to do that, and how accurate I will be in doing the so. That's all we mean by prediction. Prediction means what? Like, you always listen to the med department, that some this thing will come, the sunlight will be this much, or the day duration and all those predictions, whether there will be cooler months or rain is going to come, and all. So that's based on the previous a lot of other data and modeling. So this is a simple example of prediction, where I want to make the prediction of the length of hospital stay using the age of the person. Yes, so can I see the chat box? Has someone written something? Okay, Lakshmi has written good afternoon. Good afternoon, Lakshmi. So, okay, if not, then I'll just show the simple formula. Okay, Selvaraju has written like 3 plus a by 10 minus 1, where a is more than 10. Okay, yes, that may be, but it looks a little, uh, maybe if you see 3 plus a by 10. That may be again, maybe an accurate one. Munisha is writing 3 plus x. But if you see the formula, if it is like 2 into 0.1 plus into 2 plus 0.1 into age. That's the formula, because yes, you are right, Selvaraju, at least you have given this in the form of a intercept and in the form of a like a plus bx, because generally this is the linear. Okay, yes, 10x is equal to, oh, Munisha has also written like 10 multiplies. Okay. So this the equation which you can see here, it's the if you see these two, length of stay, so length of stay is equal to 2 plus 0.1 into age. That's the simple formula. Like, if you take this example, let's say this 50. So if I have to predict 50, if I have to make a formula, so will it fit into that or not? So I will make like 2 plus 50 multiplied by 0.5. It will be 0.1, it will be 6, and plus 2, it will be 8. So it is not, if you see 0.1, so it is the age. So age 0.1 will be 5, because 50 into 0.1 is 5, and then 5 plus 2 will be 7. So this 7 is going here, like length of hospital stay. Similarly, so we can replace this formula with or this equation with the linear equation, that is the y is equal to a plus bx. So you all know that this logistic regression, what we are doing today, that the background is from the linear regression, because linear regression, we want to make that prediction where the variable or the dependent variable is a continuous in nature. So that's why here the dependent variable, which is the length of hospital stay. If you see this y, this is a dependent variable here, length of stay. And since length of stay we are measuring in the days, that is a continuous variable. And this y or this 2 is the intercept, which is the a. And this 0.1 is the multiplier and this age is another predictor. So this is in the form of a linear equation. So with the help of this equation, can we predict the length of stay for a 25-year-old patient, 25-year age patient? So probably I have to run a Zoom poll for this, and you all please respond to this. So you must have gotten a Zoom poll on your interface. So kindly respond to that. So Dr. Anuradha is writing 4. If I have to see for the 25 year. So if you multiply 25, it will be 5.4 days. Actually, correct response will be 2 plus and 25 multiplied by 0.1 will be, so it will be 4.5. I think correct answer. It's not there. It's the answer. If you see typo, there's a typo. Instead of 5.4, it should have been 4.5.
I think it's typo.
Yeah, there's a typo error. So it should be 4.5 because 2 multiplied by, if you see this, 25 multiplied by 0.1 will be 2.5. So 2.5 plus 2 will be 4.5. Now, if you see the actual this thing here, so 20 is the age and the length of hospital stay is 4. So you take any example. Let's say you take this 10. So if you predict like, if you take the year as a 10 year, then what will be the length of hospital stay? It will be 3. And the actual is also 3. So can you appreciate that the predicted stay in this table is equal to the actual stay? Can you say, please write yes or no? If this is the like age and this is the length of hospital stay, using this formula, can you say that the predicted will be made from this formula? And this column which you can see here, that's the actual. So if you use this age group like 20, 10, 30, 40, 20 and 50, then can you say that the actual stay and the predicted stay are same? So yes, most of you have answered yes. So Dr.
Ma'am,
Arun Singh has raised his hand. Yes, Dr. Arun?
ma'am, how do we know that this equation is correct? I mean, is there any test to find out that what we are inferring is correct or not? For example, how do we know that this intercept is uh, should be 2 only? How do we know, ma'am, that the beta coefficient should be 0.1? I mean,
Okay.
is there a way?
Yeah, definitely. Actually, what we have done this, if you enter this data in software and if you apply linear regression, it will give you this equation. So the main is like we don't, since this is a small data set, that's why we have asked you to do that. Otherwise, this is done by the software where it does the, like you can only cross check it with the help of a software, because they run this mathematically and then they give you a formula with regarding the coefficient. So like Simple linear, and this is an example of simple linear regression. Simple linear regression means there's a one predictor variable and there is a one target variable. So here the target variable is the length of stay and the predictor variable is age. So that's why with the help of that you can cross check. That's the only this thing. And this is just to with this we have only given with this 5, 6, 7 data set so that it will help you to understand the importance of what is the prediction, what is the actual, and by this concept we want to introduce a concept of residual which we'll see subsequently. So I think I don't know whether I'm able to answer your query or not. So you asked like
And
how can we check, right, the
yes,
accuracy of this coefficient and the intercept. Am I right?
yes, ma'am. Yes, ma'am.
Okay. So this you can like this again. This is an example which is a dummy example of showing it to you. But for a large data set, generally how we make these equation, we don't make it manually. Rather, we always go mathematically using a software. So by that only we can cross check whether the coefficient is correct or not and the intercept is correct or not. Okay. Am I making myself clear to you or
Yes,
like,
ma'am. Understood. Understood.
okay, okay. Thank you. So now, in this case, you can see that the length of stay, actual and the predicted, both are like same. It is equal. There is no difference. So this is a simple linear equation, and you know that in biological world, this is not so simple. Why? Because it's not governed by a single variable, as you can see. So if you have many variables in question, we can change the data. Now you can see the same individuals, but the length of hospital stay is different. You can see like it is 4 days with 25 days with 10 year of age, 30 with 30-year-old person, like with if you see this third row, then with 30 here it is 11, again with 20 here it is 7. So you can say at one place it is 4 and at other place it is 7. So there is a mismatch. Means in the earlier example it was same for 20 year, it was same for all the 20-year aged individual, but here you can say one person 20 year, the length of hospital stay is 4 year, another person same age but the length of hospital stay is 7. So you can see that it is not only the age, rather the other factors are also there in play. And this is not explained, this we cannot explain by simple that point two, the 2 plus point 1 into age. So that is not no more valid here. So how will we take out the equation, that equation which we were talking? So then in that case, B, it is difficult to find A and B. And like Dr. Arun has just asked this question, how to verify whether it is correct or not. So what we did, like if you like and make this data set, import this data set in Jamovi or any other software, then it will give you a estimate and it will give you a intercept. So here the new formula would be the length of stay is equal to it is not only 2, rather it is 2.17 and plus is 0.26 into age into year. That will be a single like with a single predictor variable you can tell about the target variable. So this is the newer equation, and thus that we have like use the Jamovi to use that. So we will now have another poll, and just a sec. So another question for you people. So with the help of this equation, here it is written, can you predict the length of stay for 25-year-old patient? So this is the question. You have to predict the hospital stay for 25-year-old person. So what is the, if you see what is the equation, it is the 2.17 plus 0.26 into 25. So I think 4.5. One person has answered 4 days. I'm waiting for more responses so that if I multiply it, it is like 4.5. Let's do it. If I have to do it in the calculator,
लगता है इसका गड़बड़ हो गया है इसका
the response, the answers are not same actually. There is some error in the answers. That's why.
5 point
Never mind. I'm calculating it in front of you people, so we will see. There's some issue with the answers of this Zoom poll. So we'll see it is 2.17. So that is this thing. And next we'll multiply 0.26. So 0.26 multiplied by 25. So it is 6. Okay. 0.26 multiplied by, no, it's a 25 here. Okay, 20. In the question, it was 25 actually. So if I multiply it for 20, it is 5.2 and plus 2.17. So plus 2.17. So the actual length of stay will be 7.37, which was not there. Yes, you are right, Dr. Darkoi and many other people. And I think Shweta has written 8.67. Yes, you are right. It will be 8 because initially it came out to be 6. Yes, Dr. Arun, you want to ask something?
Ma'am, this is a basic question. In this equation for ma'am, linear regression,
Mm-hmm.
what I understand, ma'am, the intercept here is 2.17. Ma'am, that is the point on the y-axis from which the line starts, right, ma'am?
Yeah, you are right. You are
So,
right,
ma'am,
absolutely right.
ma'am, how do we make students understand when somebody asks a question that where does it fit in the entire equation? I mean, how do I say that what does 2.17 actually means, ma'am, in the entire spectrum of things, ma'am? For example, age and the length of duration of stay, ma'am.
You want to say that intuitive meaning of this intercept in
Yes, ma'am.
context of
Yes, ma'am.
biological world, right?
Yes, ma'am.
Okay, so actually the intuitive means say that whatever your value will be. So initially, even if it had, how do we actually interpret intercept? We say that if you make this variable 0, like age in years is 0, like we explain it in mathematical terms only. So if you make the age 0, what will happen? The length of stay will be, so intercept is defined as when there is no predictor, means predictor variable is not, I mean, you can say that it is 0, that value of the predictor variable, and then what is the dependent variable that will be equal to the intercept, that we define by mathematical term. And then in the intuitive meaning you can say that it means like there is this age, we call it as a centering of age, means like if that y-axis, whatever you are saying, that whether that line cuts, if you just can recall that linear regression line, then it starts from whatever will be the value, it will at least take this 2.17. So after that only this prediction starts. So any value will take this 2.17, whatever value of this predictor variable you take, and it is equal to the dependent variable when that predictor variable is 0. So that only I think I can say, because this intuitive meaning to the students, if you can ask, uh, because since it is mathematics, how to make it intuitive, I think then I will also have to think in this term. Probably let me explore this especially. in this context how to convey this. And probably maybe I will be able to answer this tomorrow because I have not thought of this way. Uh, Mainly we have thought in terms of mathematical. So probably Dr. Arun, if you can like give me today's time, then probably by tomorrow I will definitely explore the intuitive meaning and I will tell.
Okay, thank you, ma'am.
Okay. So yes, there is some ambiguity in the question because in the Zoom poll question it is 25 years and here it is 20 years. So depending on whether it is 20 year or 25 year, now you know how to make this prediction with the predictor variable, and you want to tell about the this target variable. So this we have seen this. Now I see that this 20, if you see that age in years, so if you see this 20 year, so for 20 year, what will be the, if you see the age in years, it was 7 point something. Yes, for 20 year, it was 7.2 or 7.8.67 was for 25 years. Yes. So for 20 year, it is 4. So what do you say? What do you see here? The age and this was that 7.27 or whatever it was coming, that was as a predicted one. But what is the actual stay? If you see the actual stay here, the actual stay is 4 days. Okay. So this 4 days is, we can say that this is the predicted one. This is the actual and that 7 days is the 7 point something days is the predicted one. So can you see that there is a difference observed and the predicted? So there is a difference of the stay between the observed and predicted. So predicted is 7.4. So what is the residual here? Can you calculate residual? And what is a residual actually? So for those of you who don't know the residual, what is a residual? So residual, we say that in terms of error. So whatever the difference between the actual and predicted, that is known as the residual. So since it is the predicted length of stay as per equation is 7.4 days and the observed length of stay is the 4 days. So yes, all of you are right. It is Lakshmi. It is 1 point. It will not be 1.27. Rather, it is 3.4. I think 1.27 will be for some other value of the age. So yes, you are right. It is the 3.4 days. So things will become more complicated when we consider other variables. Like it is not only the age, rather there will be other comorbid situation like diabetes status or severity of any disease or probably the ICU, the length of stay in ICU and many more. So that's why you see that the if you calculate this equation, if you calculate this length of stay, then it will be like intercept, which is A, and then B1 into age plus B2 into diabetes. So I am now speaking about this equation. So if you see this equation, so this various like B1, B2, B3 and B4, these are like the days in these are the uh, coefficient for the various predictor, and the various predictors are the age, diabetes status, severity and days in ICU. So this is the multiple linear regression. The previous example where we only took one variable, one predictor variable, which was the age of the person, that was a simple linear regression. When we take multiple predictor variable to predict about the dependent variable, then it is known as the multiple linear regression. So now if you see these two, like in this case, you can see there are 10 students, and in this column, there's a marks of the students, and then here it is the attendance, and then there is a marks out of 100. So can you make any relationship between marks and the attendance? So like you can see here, it is the 52% and marks is 68. Then you can see as you increase the attendance, let's say it is 80, then marks is 90. I think maximum is 80% attendance. Again, it is 80, then marks is 94. So Dr. Akash is writing, Dr. Divya, Implications of residual value. We'll come to that, Divya. Implications of residual value is like the more is the residual, the less accurate your model will be. That means if I say like if I want to predict the NEET PG or NEET UG marks based on the other, like in which coaching the person is studying, the age of the person, what attempt it is, and like if I say that yes, you will definitely crack NEET or you will get admission, and if you don't get, then my model is very poor. So if larger the residual will be, the prediction will be inaccurate. No, many times we see that we always say that med department has got a very good prediction because they run on, like, there are satellites and other input variable is also very accurate. So that's why, depending on the data, if you have got a good data, then definitely the chances of your accuracy of your model is high. So basically these residual, the amount of residual, the distribution of residual, the error associated with them, that determines the accuracy of your model and your prediction. That's the implication of residual value. Did you get it? Like, then you will not believe na. If you say to some person that you will stay in this hospital for 10 days and he gets discharged in 3 days, then what he will say to you? The doctor, Saab, you don't know, and I think what prediction have you made? So basically, in all these linear regression and this logistic regression, all these predictions, even in ANOVA, all the analysis is done on this residual only. Like based on what is the difference between the actual value, what the patient, what you have entered as an input, and what equation it is making, that mathematical equation. So what is the cutoff, or who decides the cutoff? Here we have not started talking about the cutoff. Cutoff of what, Dr. Divya? Are you asking the cutoff of attendance marks or cutoff of residual? I didn't get the question. Cutoff of what? Which variable? Residual. Residual, we don't decide any cutoff actually. Residual, we see the distribution. You see the assumptions. Actually, all these models, it has got many underlying assumptions. If those assumptions get satisfied, then only there is accuracy, or you can say that that's why wherever you write your result of these prediction analysis, you should always write the assumptions well. Like many table, you will see the people write that no, assumption of autocorrelation was not met, or maybe multicollinearity or linearity. So based on those assumptions, you decide whether your model will be successful or accurate or not. That's the only. Else, for residual, we don't take any cutoff actually. The background analysis is done on that. Dr. Arun is asking, how do we decide which predictors to take? Yes, that we will definitely deal, Dr. Arun. Generally, we run in case of a linear this logistic regression. So I'm no, I'll there are ways to do that, but for logistic regression, generally we take those variables where the cutoff, the p-value, we you do the unadjusted odds or the 1 to 1. That we will discuss how to take, Dr. Arun. We will discuss it at length when we are building the model. But for you right now, just to get the one, if you want in one sentence answer, then first we check it as a unadjusted odd. Means we only take one predictor variable and see the odds and see the p-value. But I think rest of the participants will not be able to be on the same level what we are talking, Dr. Arun, because everyone is on the different level. So probably if we let me bring those students to your probably the rest of the people level, and then we can discuss these questions probably. Is it okay? Okay, Dr. Arun. And answering Dr. Divya, so ideally we say that there should be no residual. Means the your model, if you are making very accurate model, then there should be no residual. Your predicted value and ideal situation, but that's an ideal situation. We seldom reach that or achieve that situation. But generally, the lesser the residual, more accurate your model will be. So yes, we were discussing regarding this attendance, and many of you have written yes, more attendance, more marks. Similarly, if we again, I have given you another example of duration of exercise and the fasting blood sugar. So can you see any relationship in these two, duration of exercise and the fasting blood sugar? Sorry. Yes. This example. So Dr. Priyanka is writing more exercise duration, less fasting blood sugar. Yes. So it is negative. In first case, you say you have seen that it is positively it was correlated. The term correlation we have not introduced, but I guess that you all are familiar with this term. Like if one variable increases, the other variable also increases. In case of a like negative correlation, if one variable increases, the other variable decreases. So based upon these observation, we can say that we can predict the marks obtained by a student if we know their attendance. And right now, I'm in for both these cases, I'm only taking it as a single variable, single predictor variable in case of predicting the fasting blood sugar, and also the predicting the marks obtained by the students. But now I am again, if you see this, we have added one more variable of gender. In the previous one, it was not there, but if you see this in both the cases, whether it is marks obtained by the student or the fasting blood sugar, I have added one more variable, that is gender. Okay, so can you observe any difference in the both data set if I have added gender? So let's focus first on this, the first one, the gender and the duration of exercise. So what have you seen? What are you seeing here? A male is doing 50 minutes of exercise, fasting blood sugar is 96. If I see female, female is 39 year, duration of, sorry, female, it's not the age, rather it's the duration of exercise. So female is doing 39 minutes and the fasting blood sugar is 125. Again, if you see this female, this is doing 45 minutes and there's a female who is doing 55 minutes. So in this case, we can see that both male and female, like they are having a variable level of duration of exercise. But in this case, in the second example, if you see that male is doing 50 minutes, but all the women, these two and these also, these two, they are doing exercise less than 50 minutes. So all men, they are exercising for more than 50 minutes or 50 minutes. There are except few, and the women generally they are exercising less. But if you see the blood sugar, yes, there is a variable level of blood sugar in all these data sets. So now we have to see between the relationship between the gender and exercise. Is there any relationship between the gender or exercise or not? And that we call it as a interaction term, which we will see later. And if time permits today, if not, then we'll discuss tomorrow. Because if there is a relationship between the two variables, the independent variable, and they interact with each other, then definitely it affects the outcome variable. So till now, we are predicting the values of a continuous outcome in all these cases. So the closer this predictor, as Divya was asking regarding the residuals, so the closer this predictor value, the better is this equation or the model. So if we wish to predict the fasting blood sugar based on gender and duration of exercise, we recruited 10 persons, asked their gender, duration of exercise, and measure their fasting blood sugar. And like we have used this data to develop a model. So which of the following is the best model theoretically? So we are asking theoretically. So here you can see three models. This is model 1. This is model 2. And this is model 3. Okay, so can you put that chat box a little up? Yeah. So which is the ideal model in this case? Theoretically, of course. So if you see first model, the actual is 96 and the predicted is 100. Similarly, actual is 118 and predicted is 116. If you see model 2, the actual is 96, predicted is 130. Actual is 125, predicted is 105, 98 and 92. If you see the third, it is 96, 96, 118, 118, then again 130, 130. So it's the same question of Divya which she asked, like what is the value or what is the rationale of knowing these residuals. So you can see in case of third model, this one, third one, the residual, the actual and if you see this third model, the actual and predicted it is almost the same. Although we know that it is the same. I mean, it is the there's no change. So Dr. Anshuman Abhishek is asking how to get the predicted value. So predicted value will be based on the equation. So predicted is generally the software gives you the predicted value. Whether it is SPSS or GEMOV, based on probability, it calculates the predicted and it gives you the predicted. Is that okay, Dr. Anshuman? You don't have to do that. Right, currently. Based on that, we make equation and that it gives you the predicted value. So and the actual, you get that from data. So that's how you make the equation, because whatever data you feed, it calculates a predicted equation and that calculates the predicted value based on mathematical equations, and then you have got the actual value. So it calculates residual based on that. So now, because these linear regression and these logistic regression, these are all mathematical. They are types of modeling or the prediction which uses the mathematical equation. So based on that, the software calculates. So you can see, and if you see, if I ask you the question, so third is the ideal model, but it is not a practical model. If you see the second model, so second model was full of error. There was a huge difference between the predicted and the actual, and that's why that's not a good model, and the model one is a practically possible model. So for a linear now this till now we have discussed the linear, because all these were the linear equation, all these assumptions. What are the assumptions which should be met if you want to make why we are discussing linear regression, we are building the concept. Now I will tell you the assumptions and then how this logistic regression, how to move from linear to logistic. So for a linear equation, whenever you have this y is equal to a plus bx, the following this thing should be met. So how do we do that? We call it as a linear relationship. So we call that independent variable and the dependent variable should have a linear relationship. In this case, you can see, like, as the duration of exercise increases, in this case, the fasting blood sugar also increases. If you see this, so this is the if this is decreasing, but definitely it is linear. If you see the line, there is a straight line and it is a linear regression. It is the same line for that data which you have seen earlier. Now coming to this is the one assumption. And then the second assumption is the residual should have normal distribution. So this is the residual which we were talking, and this is the difference of residual, actual and normal. So if you see this is the residual, and you plot a QQ plot or a PP plot of this residual, and then you see its normality, whether it is normally distributed or not. And then how to complicate this situation further. So if this is the data set now, in this data set, what change you can see from the previous one. So if you see this, now focus on this variable, diabetic foot. Here it is the duration, in the previous exercise, we have taken the fasting blood sugar. But now, instead of fasting blood sugar, we have taken the presence or absence of diabetic foot. Similarly, in the initial exercise, it was the marks obtained out of 100. But here, what I have done, it is the pass or not pass based on the marks obtained. So how this new one, this one, if I ask, how this is different from your initial one, this one. What is the difference between these two? Yes?
It is not a continuous data.
Yes. So very right. You can see here that here it is a continuous. If you see this example, here it is a continuous data. But if you see, this is in the form of a present and absent. Present and absent. That means it is yes, Priyanka is right. Output variable is a binomial. You have got two categories. Similarly, in marks obtained also, you can see the binomial variable. It is a pass and not pass. So we have categorized these continuous, like marks obtained total. We have categorized, like let's say if my per passing marks is 60%, then I have categorized it using the pass and fail. So I have used this as a categorical variable. So I will have to make equation like this, because for categorical variable, how will you make a equation? So you will make like diabetic foot, yes and no, because it will be a categorical, and then A plus B1 into gender and B2 into duration of exercise. And similarly, 1 is 0 and 1 is yes is 1 and 0 is no. So I have to make an equation like this where 1 is yes and 0 is no. So, but how will I make a equation? Because I have got only two values. If you see a linear equation, the dependent variable should have a range of values. If I talk about this value, this is the dependent variable or the y. So if I have this value, this should have a range of value. But I have only two values here, 1 and 0. So how to make a equation then? Because I have got only two values. So linear equation prediction is only possible when the outcome has a continuous value. So now how to change this outcome into some continuous value? So what is the solution? So what we do generally, not what we do, what this software does, it calculates the probability of the occurrence of outcome of each case. So all this calculation that is done on the probability. So if you see this, the software calculates the probability of the occurrence of a male 32-year age who is doing the 50 minutes of exercise. What is the probability of the occurrence of diabetic foot? Similarly, if you see this female, this software calculates that what is the probability of occurrence of a diabetic foot in female who is 55-year-old and who exercise for 39 minutes. So the software calculates the probability. Likewise, every probability will be calculated for these case. Now, if this is the predicted probability, like Dr. Abhishek was asking now, how it calculates the
We'll see.
predicted. So we will see in the software also, we will see how it is done. So this you can see here, like this is a 32-year-old with the 50-year duration, and this is this diabetic foot. This is the actual situation. This, if you see this, this is the actual patient situation, and this is the predicted probability of the this particular person. Now, the calculation of predicted probability, we will see how it is done. And but we know that probability, if you know the probability has got a range of value, no doubt. Unlike yes and no, where you were having only two values, 0 and 1, a probability will have a range of value, but the lower will be like 0 and the higher will be 1. Means it cannot exceed 1, but it cannot go to negative also. Okay. So right now, I am just telling you how this, what assumptions do we have to make so that we can apply this linear equation. So what, like in this case, yes, Dr. Darkoi is right. It is the linking function. I am coming to that, but probably a little later. So now, based on that probability, how will I decide? So we know about this probability that 0 is having no chance of outcome occurrence and 1 is having definite chance of outcome occurrence. Okay? You know about that a probability, if value is 0, we call it as a no chance of outcome occurrence, and 1 if there is a definite chance of outcome occurrence. Okay? Now, you all have to write in the chat box for each value of probability, write your anticipated prediction of occurrence of outcome. If the probability value is 0.12, I'm asking you people to write about 0.12. If the probability value is 0.12, what will you write? Whether if 0 is no and 1 is yes. Okay. So Dr. Darkoi is writing not occur. Okay. Any other person? I'm asking this first if the probability is 0.12. This 0.12 is near to 0 or near to 1. Okay.
5% chance, ठीक है.
Okay, 12%, 12% chance of occurrence, that is okay. But I am asking,
less
okay,
chance.
very less chance. Yes. If probability is, it is near to zero, you have to see whether it is near to zero or near to one. So if it is near to zero, we will call it as a no chance of occurrence. Then if you see this, the next one, which is 0.93. What is your stake on this 0.93? It is near to 1 or near to 0. 0.93 probability.
High chance.
High chance of occurrence. Now, what about this 0.55? Because it's in the middle. Okay, so Dr. Anindya is writing near to, okay, it was the moderate chance. Okay, yes, moderate chance. So now for 0.12, that is okay. You people have written that
Yeah.
0.93 and 0.12 is very clear. But 0.55, again, it is difficult to decide because you don't know. So how to resolve this dilemma? If it is like moderate chance, like 0.55, so we need some rule or some probability rule to decide about this. So the rule is what the software, all software, whether it is SPSS or Stata or Jamovi, the software has set a rule that if the probability value will be less than 0.5, then I will say that outcome has not occurred. And if the probability value is zero point 0.5 or more than 0.5, then I will say that outcome has occurred. Okay. But again, by default, it is zero point 0.5. Software has set zero point 0.5 for that. But if you want to increase this cutoff of probability, you can change this definitely. But generally, we don't change because 0.5 is okay. So that's why by default it is 0.5. So now what take home message we have taken? That if the probability value is 0.5 or more than that, then we will call it as the outcome has occurred. If the probability value is less than 0.5, we will say that the outcome has not occurred. Okay. So to the previous question, how the calculation of probability will help us in the formation of linear equation. So now what will I do instead of, so initially in the dependent, so you know what I am doing. So since beginning, I have started with a linear equation, simple linear equation, where the dependent variable was a continuous. Now I have converted that continuous dependent variable into a probability. So instead of using yes and no, what I am doing now that I am taking this dependent variable as a probability. So is this probability is a continuous in nature? Yes, all of you please write yes or no. Because to form an equation, I need something. So Priyanka is writing yes. Probability, yes, it has got a range of value from 0 to 1. So now I have converted my all that prediction value in the probability. So now I can take this as a dependent variable. But now what problem do I have? Because I know that probability has a value of 0 to 1. And for a linear equation, my line should go from minus infinity to plus infinity. Okay, because probability cannot go beyond less than 0. It cannot go to the negative. So for linearity assumption to be met, for that my line, which you can see here, it should not only go to the positive side, rather it should go to the negative side also. That means they should go towards the negative also. And that's how we can do that. So if you convert this probability into odds, then odds can go both into the negative and into the positive. So probability, how we can convert these odds? So probability can be converted like I was not like it can go to less than 0. It is not negative, like it can go to less than 0 value also. So if you see this odds, how we can convert this odds into probability or the probability into odds. So we can convert it using this formula where odds is equal to P by 1 minus P. Means odds is equal to probability of something happening, and in the denominator we take as something not happening. So that's why if I have to calculate the probability of occurrence of a diabetic foot for a person is for any person is 0.75, then what will be the odds? Yes, odds can go to less than 1. Very right. We will see that. So odds is like 0.75, and in the denominator it is 1 minus 0.75. So it is 3. Now, if you see this, this is the predicted probability. And if you see this, it is like it can go if you see the odds. So odds is like 0.06 if the probability is this. So what we have done, we have calculated the predicted odds from this predicted probability. This is our predicted odds. So now we can have our linear equation, like we can have this odds of a diabetic foot, because this can go with, yes, you are very right, Dr. SV, that infinity means like positive. I was meaning like in case of this thing, after 1 it cannot go, but this odds can go beyond 1 also. So these values, the odds can range between definitely that what we say, negative, you are right, negative it cannot go, but yes, towards the positive side it can go. Like in this case, you can see the odds is going to 25, this one. It is going to 25 also, it is going to 2 also, but in case of probability, if you see, it will not go beyond 1. So I'm sorry, I said negative, but it should not be. I should have said like it can go beyond 1. So that's why if you convert these probability into odds, it will not be restricted. Yes, I'm coming to your link function. It is not restricted to for the upper this thing. Means like it will go beyond 1 also. So we can have our linear equation. Now what I have done, I have converted that probability into odds. So now how can I write my equation? So I have written my equation like odds of a diabetic foot, and then I have taken like A is the intercept here, and then again the same predictor, 3 predictor variable, that is the gender, age and duration of exercise. But still odds as it has got an issue, because the value of odds is asymmetric around 0. So how we can do that? So like you know that odds is not symmetry. So if like odds, if you focus on this first, if I say that odds of a diabetic foot in male is 2 times higher than female, can we say that the odd of diabetic foot in female is 0.5 times lower than males? Can we say like that? Because you know that if we change the reference category, how do? We do like 1 by that much odds. Like if it is 2, then in case of a female, I can write like 1 by 2, then it is 0.5. Similarly, if I say that odds of a diabetic foot in male is 3 times higher than females, then can I say that odds of diabetic foot in the second example? If I take the second example, this one. So can I say that the odds of diabetic foot in female is 0.33 times lower than males? Yes, I can say that, because what I have done there, here in case of a female, I have done like 1 divided by 3. So this is how we calculate the odds, and this comes as 0.33. Similarly, if I say that odds of a diabetic foot in males is 4 times higher than females, if I have to calculate in females, what I will do? 1 by 4. So I will write here, and this comes to 0.25 times. So it is 0.25 times lower than male. So, but this is not symmetry, because if we change the reference category, it doesn't make the symmetry. What is symmetry? Symmetry means if I say that I am twice taller than you, then I have to say that you are twice less than height in as compared to me. So that's the symmetry. So but in case of differences, uh, if I say in case of a differences, because that's the odd, but if I say that if my fasting blood sugar is plus 20 higher in male, then I can say that the fasting blood sugar in female is minus 20. with respect to male. Similarly, what I was saying with as compared to, so in case of a differences, I can observe symmetry around 0. Similarly, if I say that my fasting blood sugar is 8 milligram deciliter lower in male as compared to female. So I can say that the female has 8 milligram deciliter higher blood sugar as compared to male. So this is symmetrical. What do I mean by symmetrical and asymmetrical? This is example of a symmetrical, because here the male has got plus 20, then female has got minus 20. Again, male has got minus 8, so female has got plus 8. So it is example of symmetry. But this is not symmetrical. But odds has got a problem because it is not symmetrical. So how will I write that? Odds of a diabetic foot. If I take female as a reference, then I'll have to write 4. That means the odd ratio. And if I take male as a reference, then I'll have to write 0.25 here. Why? Because the odds is different. In case of a male, it is 4 times. I'm just replacing this with this equation. If it is 4 times higher, then I will take this equation. If it is 0.25, then I will take this equation. So I'll have to make 2 equations. But in every prediction, you have got only single equation. So how to make, in case of a reference category or categorical variable, how to make that symmetrical? So we take the natural log. So if you take the natural log of this odds, then we get a symmetrical value. Like you can do that using a natural log calculator, and this function is known as the logit function or the link function, which Dr. Dev Kari was like discussing since beginning, and many other person has also said, like if you take a natural log of this odds, which is known as the logit. If you see this, that's why this is known as the logit, then it will have a symmetrical distribution around 0. So like if you take the logit in the previous one, the 4, then it will be 1.38. And even if you take the natural log of 0.25, it will be 1.38, but it will be in minus. So how I can write the equation? I can write like logit of y is equal to a, which is the intercept, logit of b, and this is the x, which is the predictor variable, and this is the your like coefficient. So this is the logit function which we use in case of a logistic regression. So let's recap how we have built up our concept. So linear equation, it is not possible with dichotomous outcome. So that's why what we have done, we have converted that dichotomous outcome into probability. We have set a rule that anything having probability of less than 0.5, we will say that the occurrence has not occurred. And if the value of probability is 0.5 or more than 0.5, we will say that the occurrence, there was an event has occurred in that particular person. But we know that it got restricted at 1 because it will not go to infinity. Both it has got the lower and the upper border fixed. So by converting it to odds, we have tried to devise the linear equation. But there was a problem with the asymmetry around odds. So what we have done, we have used a logit function. We have taken a natural log of it, and this has got a symmetry. So if you see this, so this is the logit. If you see the probability, this is the first one. This is the probability. So we have converted this probability into odds here by using the formula P by 1 minus P. You don't have to do any of these actions. The software does everything. But you should understand what is happening at the background. That's why we are giving this example. So from this probability, we have calculated these odds. And if you take a natural log of this, then it is the logit function or the natural log. But you see that there is a, if you see, we have taken it like for all probability, and there is a symmetry. If it is 0, then it is 0.41 here minus, and this is plus 0.41. Similarly, it is minus 0.85, and this is plus 0.85. Except for this, there are plus and minus, there is a symmetry. So these logit function. So now, as Dr. Abhishek was asking, how does this software calculates the probability of individual case given the multiple predictors? So Dr. Arun is writing, this is the first time I have understood why logarithmic transformation is required. Okay, Dr. Arun, thank you. So now, again, like Dr. Abhishek has asked, like, how this predicted probability is calculated? This was his question when we were discussing those predictions and probability. So actually, there are multiple variables, and then you have to calculate the probability of individual cases given the multiple predictors. So there is a technique known as the maximum likelihood technique. And based this, which is also known as the MLT, or many time you will say it is written as MLE, maximum likelihood estimation. Or using this maximum likelihood technique, we are not going to tell you the mathematical this thing, because even I don't know. Yes, you are right that using multiple iterations. So that's it's a technique where it does the multiple iterations, and it tries to calculate it using the most you can say like which is the feasible or which is accurate. So actual calculation is a complex process, but just for understanding, we have demonstrated few of it. Let's see. Okay, so logistic, let's see if I can. Okay, so maybe that Excel file, I'll try to show this later. So this maximum likelihood, actually what it does, it takes each factor into account, and it calculates the probability using this, Dr. Devkari has said, using the multiple iterations. And based on that, it makes an equation in the background. You can see here, this is the equation like logit, and then a plus b1 into x1, b2 into x2, b3 into x3, and so on. And these b1, b2, b3 are the estimates associated with each predictor variable. So to get the best value of b, which is the estimate for each predictor variable, so that each case can have maximum possible value of a probability, so that software does it like many of you have said that in multiple iterations, it calculates these probability. So that was regarding the basics of, we'll see all these concepts we'll see in Jamovie. There you can actually see the this probability, and based on that, how to assign that group membership. So you can see here that there are two. So in logistic regression, we have two set of variables. Generally, we name the two types of variable. There is a response variable, which is also known as the outcome variable, or which is also known as the dependent variable. And then there is a independent variable, which is also known as the predictor variable, or which is also known as the explanatory variable. There are the various names, like books and articles they have used, but these are the names like dependent variable, outcome variable, or the response variable, and then independent variable. So if you take that equal to sign, left of equal to is the dependent variable, and all those right where you have calculated the estimates, those are known as the predictor variable, or the independent variable, or the explanatory variable. So these are just example of categorical variable, like whether an admitted newborn will get a sepsis, whether a family will fully immunize a child, whether a mother will exclusively breastfeed her baby, whether a pregnant woman will have preeclampsia. So all those are predictions based on the predictor variable. But there is a problem, which I think Dr. Arun asked this question: how to select out of many predictor variable, because there are many variables in your data set. So basically that is dependent on two criteria. First is the sample size, because to calculate to have a valid prediction equation, you should have enough sample size. The second is if you have enough sample size, like in this case, you can see I have so many predictor variable, gender, serum sodium, urine output. Maybe let's say if my prediction is mortality, age, SpO2, attendance, diabetes, and all. Yes, Dr. Darko is right. Significance in bivariate analysis. Yes, you are right. Uh, that we'll see. And again, even if it is not significant, but you think that if you have done the literature search and if you see that it is one of your important predictor variable, then you can use that. But you should be you should make sure that those many samples should be there. Samples mean sample size. So first we should choose few probable predictor variable depending on the literature search and as a clinician or as a researcher, which can predict the outcome of interest. So suppose, for example, I've started or I have sorted out 10 probable predictor variable, and I think that these are the predictor variable based on which I want to make my model. So I will now run the statistical analysis, and that's the rightly said. We need to do a bivariate analysis. We call it as a like unadjusted, like you take one independent variable and then you calculate the odds ratio and see the p-value. So when you see the p-value and then you generally you are a little lenient in that, and it is said that generally the cutoff of p-value we take at 0.05. But in case of selecting the predictor variable for our dependent variable, we are generally a little lenient and we keep it at a level of 0.2. So we select those variables where the p-value is up to 0.2. It should not exceed 0.2 because then there are chances that when you run a multivariable logistic regression, then there are chances that it may become significant. So the predictor variable, whether it should be categorical or continuous, so it can have anything. And you can have a predictor variable whether it is continuous or whether it is categorical. But many times you will see that generally people take mostly the categorical variable because then interpretation probably it is easier for them. Or but again, you can have a mix of that because all the models you can have a continuous variable as a outcome as a continuous, or a categorical variable as a predictor variable. Then we call it as a why should we should be lenient in selecting the significant predictor variable. So this was just one example. Here you can see this we have taken from one article. I'm sorry, we should have given the title of that article. So there the person was like he wanted to predict the postpartum depression using logistic regression, and these were the variables like vitamin D level, age, if you see this, age, BMI, education, high school, and good. So if you see, this is the odds ratio, which is the crude odds ratio. What is the crude odds ratio? When there is only single predictor variable and you calculate the odds ratio, then it is known as the crude odds ratio. When there are multiple predictor variables, then it is known as the adjusted odds ratio. Okay. So if you see this, pardon? If you see this, this variable, this is not significant here. It is, since the confidence interval, it is like having a value 1. So we can say that it is not significant. But here you can say that after taking this into adjusted, it has become significant. So yeah, you will see nearly means like, yes, it is 0.05, but maybe at least it has come to borderline significance. So that's why we take a value cutoff of 0.2 for the selection of variable. So if we have started with 10, so we may have all 10 probable predictor or none of the probable predictor or few of the probable predictor, which is the most common situation. So now what to do? So we need to select those final selected predictor variable for logistic regression and then we will put that into the model. So again, this is the same repetition. Like in logistic regression, there is a probability that dependent variable we convert into log odds by finding the natural log. And this is again, it is about predicting a binary variable. So I think it is also, we in this session, today's session, we are going to talk about the binomial. There are other types of logistic like ordinal and multinomial, which we will, and the conditional logistic, which we will discuss later. Today we are going to discuss about the this binomial where the dependent variable is a category having two categories. So there is a dependent variable which is dichotomous in nature, and that's why it is a binomial logistic regression. And the independent variable can be both continuous or categorical. So again, for those of you who gets confused between linear and logistic regression, so in linear regression, the dependent variable is continuous, and in logistic regression, the dependent variable is categorical. So this is logistic regression. Again, if there is such question is if I want to predict at the time of admission which patient of COVID may need ICU, so which type of regression I should be using, linear or logistic? Yes, all of you please type in the chat box. Logistic, yes. Rightly said, because the variable, the dependent variable is the whether they need ICU or they don't need ICU. So measuring odds ratio in logistic regression, we talked about unadjusted odds ratio. When there is one independent variable, it is known as the unadjusted odds. When there are more than one independent variable, then it is known as the adjusted odds ratio. Okay, so now coming to the assumptions. So up till now, do you have any? Okay, so there's one hand who has raised. Can I see the name? Dr. Arun, yes?
Ma'am, thank you, ma'am, for allowing me. I'll be very quick. Ma'am, you said that when there is one predictor variable, then it is unadjusted, and then when there's more than one, there's adjusted. But in the table that was projected when you were explaining and building up the concept, just about 3-4 slides back from the current slide. Yes, ma'am.
I'll go
Ma'am,
ahead.
the postpartum depression.
Yeah, yeah.
ये बताने की
मैम
जरूरत
जी मैम मैम इसमें इफ वी सी मैम लाइक एज का जो क्रूड ऑड्स रेशियो है वो 1.10 था और एडजस्टेड हो गया 1.14 के साथ तो मैम
Yeah.
इस टेबल से तो मैम मैम कैन आई स्पीक इन हिंदी इफ इट्स ओके
हाँ, यस यस, वेरी मच ओके। हाँ, क्या लग रहा है
मैम
आपको इस टेबल से?
तो मैम इसमें तो लाइक वी हैव अंडरस्टूड दैट द इसमें द CI is containing one and that now it is significant after we've adjusted it. But shouldn't it be a good practice to say that कि जो जिनका भी आर्टिकल था कि इन्होंने किसके साथ एडजस्ट किया है so that ma'am the reader is able to get a good idea of that because
एक्चुअली
ma'am
एक्चुअली इसमें हम लोगों ने पूरा, यू आर राइट, उनके फुट नोट में कई बार वो लिखते हैं, क्योंकि इन्होंने क्या किया है ना कि इन्होंने सारे ही वेरिएबल ले लिए हैं फॉर यू नो एडजस्टेड। कई बार क्या होता है कि अनएडजस्टेड में दे सी द पी वैल्यू, एंड इफ इट इज अप टिल 0.2 they have not given the p value here because many are not significant. If you see like age, even the BMI, and then primary education, high school, all these are not significant since the because the odds ratio 1 ले रहा है, लेकिन
one ले
इन्होंने
रहा
p वैल्यू नहीं दिया है। क्योंकि कट ऑफ लेने के लिए इनको क्या करना, ये तो हमने जस्ट एक एग्जाम्पल के लिए दिखाया, बट नॉर्मली आप देखेंगे कि वो लोग सारे वेरिएबल नहीं लेते हैं प्रिडिक्टर वेरिएबल में। इन केस ऑफ एडजस्टेड दे मिस फ्यू, वाई? क्योंकि वो देखते हैं कि जो भी सिग्निफिकेंट नहीं है वो ड्रॉप कर देते हैं मॉडल से, और
तो
फाइनल
मैम
में ना वो नहीं लेते हैं।
तो मैम ये हम मानकर चल सकते हैं कि जो एज था जिसको जब हमने एडजस्ट किया तो उन्होंने इसमें से कुछ को अपनी फाइनल मॉडल में डाला और फिर जब एडजस्टेड ओआर निकला तो वो फाइनल मॉडल का आउटकम के बेसिस पे ये 1.14
हाँ हाँ
निकला।
हाँ हाँ, ऐसे ही मानेंगे, क्योंकि एज उनका जरूर मतलब जो भी रहा होगा, इसलिए कई आप देखेंगे कि जो उसके बाद भी सिग्निफिकेंट नहीं हुए, अगर आप देखेंगे इसको, एक सेकेंड, नॉर्मली क्या होता है कि अगर उतने वेरिएबल नहीं लिए गए तो इस केस में आप देखेंगे कि मैक्सिमम वेरिएबल सिग्निफिकेंट नहीं हुए, ये सारे देखिए आप,
जी मैम।
0.87 0.80 ये सारे सिग्निफिकेंट नहीं है, इवन ये भी सिग्निफिकेंट नहीं है। तो इन्होंने सारा का सारा ही ले लिया है इनफैक्ट। तो
मैम
जनरली
जी सॉरी मैम, तो ये प्रश्न ये है मैम कि जब हम अपना मॉडल बिल्ड कर रहे होते हैं मैम, जैसे एसपीएसएस में जब हम अपना वैल्यूज को पॉपुलेट करते हैं, तो एक रेफरेंस कैटेगरी लेते हैं मैम, और जिसके आधार पे हम फिर बताते हैं कि उस रेफरेंस के हिसाब से इसमें ऑड्स कितना आया मैम। मैम एग्जाम्पल के तौर पे लेट्स से पोस्टमार्टम डिप्रेशन, प्राइमरी ग्रेविडा एंड मल्टी ग्रेविडा। तो हमने देखना था कि मल्टी ग्रेविडा में ऑड्स कितना था और प्राइमरी में कितना था, तब हम एक रेफरेंस कैटेगरी लेते हैं मैम। मैम मेरा ये प्रश्न था मैम कि जो हम रेफरेंस कैटेगरी, इसमें क्या उन्होंने कोई रेफरेंस कैटेगरी ली होगी मैम?
बिल्कुल बिल्कुल डॉक्टर अरुण, बिना रेफरेंस कैटेगरी के तो होगा ही नहीं, लेकिन इसमें क्या है ना, ये जो हमने टेबल दिखाया ये आइडियल, अगर इसको आप ये सोच के चल रहे हैं कि आइडियल टेबल है तो हो सकता है आपको उसमें बहुत सारी कमियां नजर आएंगी, लेकिन ये एक आइडियल टेबल नहीं है। अभी हम जो जैमूवी का आउटपुट देखेंगे, या हम लोगों ने भी एक टेम्पलेट दिया है जिसमें हमने ये बताया है कि एक टेबल कैसे बनना चाहिए, उसका इंटरप्रिटेशन कैसे लिखना चाहिए, उसको अगर आप देखेंगे तो आपको चीजें बेटर क्लियर होंगी, क्योंकि ये जो एग्जाम्पल है ये हम लोगों ने इस उद्देश्य से नहीं दिखाया है कि इसमें सारा कुछ उन ऑथर ने इंक्लूड किया है। इसका उद्देश्य सिर्फ इतना ही था कि जो हमने अनएडजस्टेड लिया है, कभी कभी वो अगर पी वैल्यू 0.05 से ज्यादा भी है तो वो एडजस्टेड में सिग्निफिकेंट हो जाता है, मतलब पी वैल्यू कम हो जाती है। तो इस टेबल को दिखाने का उद्देश्य सिर्फ इतना ही था, इससे ज्यादा नहीं। और जो आप बातें बता रहे हैं कि हम जो आइडियल वाला है उस पे हम अभी आएंगे, उस पे हम अभी तक आए नहीं हैं।
जी मैम, थैंक यू मैम।
Okay, you're welcome. So for rest of the participants, what Dr. Arun was asking, like, is this the model result showing template? Because he was asking regarding the reference category. So he said that the author has not given the reference category here, and neither, because always you will see that odds ratio, whatever, like in this case you can see here he has not written, like, but even the one is he has not written whether he has taken illiterate, because if you see the education, primary high school and secondary high school, many time they call it as a, here also if you see primary education, husband education, so probably they have taken illiterate as a reference, but they have not mentioned regarding the reference category. So that was his viewpoint, like they have not mentioned either the p value, neither they have taken written the reference category, but we will see how to do that. Okay, is it okay to everyone? Like, I don't know whether all of you are able to understand what the conversation was going on here, since many of you are from like the non-Hindi speaking area. So can someone confirm whether they were able to understand what discussion was going on? Probably, let me see. I can ask Selva Raju. Selva Raju, have you understood what we were talking?
Yes, ma'am.
Okay.
Yes, ma'am.
So it was just regarding the way we present the result. Let me again. So we discussed all this. Yes. So now I was talking regarding the assumptions. So do you guys need a 5 minutes break? It's 3:42. Because again, assumptions section, it is important for all of you. So you can go for maybe 5 minutes break. I'm here only. Somebody wants to like. So now coming to assumption section. So like I said that there are many underlying assumptions to make your model accurate. You know, you must be like heard or learned or seen a lot of assumptions in linear regression, whether it is simple linear regression or multiple linear regression. Similarly, one assumption of like this linearity, making this logit function, we have like tried to make that assumption, and then other we'll see. So the first assumption is the independent variable, it should be measured on either a continuous or a nominal scale. It is an other independent variable. It should be like it can be both like continuous or the categorical, and there should be independence of observation. So independence of observation means like if you have counted one individual once, then you are not going to count that individual second time. That we mean by the independence of observation. And I think we have discussed this assumption at length in many of our other workshops. For this example, I can give you like if I am taking the prevalence of antenatal depression, and if I have counted one woman once, and my data collection period is for 9 months, so one lady might come many times during my data collection period. So if I have not kept this question like, have you answered me before, then I might collect the data of one female twice. So that we mean by the independence of observation, because then there are two data in my data set which are the same individual. So that means the independence of observation assumption is not met. So that we mean by the independence of observation. So are you guys clear on this concept of independence of observation? That means each individual should be different. I mean, should be unique. It should not be the same individual. Many times you will see what we do. I have seen maybe in my time when I was doing my PG, what many people used to do, that they used to collect, let's say my sample size is 350 and I have collected 200 data. So what they used to do, they used to copy paste the same, the upper 10, then middle 10, and then lower 10, and used to increase the sample. So they used to make that 150 extra from that existing 200. So then that independence of observation assumption will not be met. Why? Because I have counted one individual more than once. Okay. Then coming to the other assumption, which is the dependent variable and the independent variable. So what should be my sample size? So at least there should be 15 cases. 15 cases means 15 outcome, because this is a binomial logistic regression. Binomial means it should have two categories. So the outcome should have at least 15 outcomes per independent variable. If I have got 5 independent variable, or I want to take 5 independent variable in my model, there should be at least 75 outcome, not the total sample. Don't get confused by this total sample. There should be 75 outcome. Means I will say, I'll tell you what these outcome means. Like if there is an outcome of, let's say in this example, surgery cancellation or surgery not no cancellation. So the surgery cancellation should be at least 75 if I want to take 5 predictor variable, and then the no will be rest of them. So this is important. Minimum of 15 cases per independent variable means 15 cases means 15 outcome. And then there is something known as the test of linearity. So yes, those of you who are doing this SPSS, you know that in SPSS, there is a procedure known as the Box-Tidwell procedure, which we use to test for the linearity. But in case of JAMO, we don't do that. And we use that using a model fit and the pseudo R-square statistics. We learn more about this, how to see the assumption. So if we see that if the model fit criteria, if the it is significant, the omnibus model test value and the R-square statistics, if it is between 0.2 to 0.4, we'll see. Then we say that yes, the linear assumption is met. The next assumption is multi-collinearity. That is an important concept, and Jamovi has got this option of testing this assumption. So what is multicollinearity? As a name you can see, multicollinearity means, collinear. Collinear means like they are having the same relationship in the same direction and they are highly correlated. So because that in case of a logistic regression, if there are independent variable, so two or more independent variables should not be very highly correlated. Why? Because then it creates confusion that which variable contributes to the variance explained in the dependent variable, and this we detect by either by the inspection of correlation coefficient, or there are two other like indicator, which is the VIF and the tolerance. So VIF is the variance inflation factor and the tolerance is the opposite of that. We will see that. What is the so because of multicollinearity, there can be problem in interpretation, because then we say that if the value of R, which is the Pearson's correlation coefficient, that should not be more than 0.8. It should be less than 0.8. But generally in JAMO or in SPSS, we do it by VIF and tolerance. So what is multicollinearity? So our data should not show multicollinearity, and it occurs when we have got two or more independent variables that are highly correlated to each other, and this leads to problem with understanding of the independent variable. So there is a situation when there are more than two independent variable and they are highly correlated to each other. So they will provide a redundant or very similar information to the model. For example, let's say if I want to predict cholesterol. So if I want to predict a person cholesterol level based on the various health related features, and I know that there are two predictor variable which might have multicollinearity. Like in this case, you know that there is a weight and there is a BMI. So if I take both these criteria, weight and BMI both, then there will be problem of multicollinearity. Why? Because BMI is derived from weight only. So there will be a problem of multicollinearity. So now the second example, if I want to predict lung capacity and I want to run a multiple linear regression, so I have taken these predictor variable. So I have taken age, height, arm length, weight, and I want to predict lung capacity. So here height and arm length, these again two will be highly correlated with each other, because we know that if the person is like of a good height, then his arm length will also be good. So this might create. So what should we do? We generally drop these variable, one of these variable, if there is a problem of multicollinearity. And how do we test that? This is again another example. If you want to predict the heart rate, and there can be a multicollinearity problem between the age and the resting heart rate. So age and the resting heart rate, these can be two variable which can have the multicollinearity, because you know that if the person is having in this case you can see if the person increases, the age is increases, then the resting heart rate also increases. So how to check for multicollinearity? So either you can see the correlation coefficient, but for that you have to run a correlation diagnostics. We don't want that. So this Jamovi gives you the value of tolerance and VIF. So remember that VIF should be less than 10 and its opposite is tolerance. So tolerance is 1 by VIF. So the value of tolerance should be more than 0.1. But don't remember both of these, because then you will get confused. So I remember that VIF should be less than 10, and then opposite will be true for tolerance. So VIF is simply the reciprocal of tolerance. That means 1 divided by tolerance. So we need to consult only one of these measure. So if the tolerance value is less than 0.1, which is the, we can say that the VIF is greater than, less than 10. So there is a problem of multicollinearity. Now there is something known as the outlier. So you know that outlier generally we, in case of Jamovi also we have seen that outlier we check by the box plot, each of the variable. And it is generally, we say that it is, if it is more than 1.5 box length, then it is an outlier. But here we check the outlier of the residual. So and there is something known as the Cook's distance, which this Jamovi gives. So that value of the Cook's distance should be less than 1. So we will see what this Cook's distance is. And Jamovi calculates the overall Cook's distance also, and it calculates the Cook's distance for each case also. Each case means each sample. So now we will see what is an outlier in context of a logistic or linear regression, any regression. So generally any anomalous data, it can be of 3 types. So first is an outlier. So outlier, what is outlier? We have learned the concept of residual, okay? So residual again can be of 3 types. It can be a simple residual, as we have seen in the initial slides, the difference between predicted and the actual. The second is known as the standardized residual. When you divide this normal residual by the standard deviation of the population, it is known as the standardized residual. And then there is something known as the studentized residual. So what is a studentized residual? In the numerator, it is the same, the normal residual. In the denominator, you take the standard error of residual. So that is the studentized residual. So you will see that all these calculation of Cook's distance and all, the software performs it on the studentized residual. You don't have to do this, mind it. I'm just telling you so that you know what these are. But when you interpret, actually, I think you don't need to remember all these types of residual and all. But I just want to tell you what is the difference between the outlier and a highly influential point. Because you will see in the textbook and in many other books that they mention all these 3 types of residual. So here, a very large residual, studentized residual, is known as the outlier. So you can see what is this? This is again a plot of outcome and the predictor variable. And you can see here that this is an outlier. So why this is an outlier? Because this value is very large. If you see this is the predictor, this is an outlier because this is away from this. So this is an outlier. But if you see the regression line, there are 2 lines here. This line is a dotted line. This is the line which is the regression line using this outlier. And this bold line is the regression line without that outlier. Okay. So you see that the slope doesn't change. Even if there is an outlier having this value, the slope is same. If you see this, they are going parallelly. So our residual or outlier doesn't change the slope of the regression line. Coming to a high leverage point. What is a high leverage point? High leverage point is something, here you can see it is a high leverage point. So this value, the predicted value, this is again a little different from other. So again, this has changed this regression line, but again to a very little, not very much. So again, this high leverage point is there. That means its value is not very abnormal, but again, this is changing the regression line. Now, when you take both these into account, high leverage point and the outlier, then both these combine. If you calculate a distance, it is known as the Cook's distance. So what is a Cook's distance? So basically, a Cook's distance is a high influence observation which is an outlier and has got high leverage. So if you see, a Cook's distance is an influential point which incorporates both these, outlier and a high leverage. Because you know that outlier don't move the regression line much, neither do the high leverage point. One predicted variable which is both as an outlier and a high leverage, that has got a big effect on the regression line, and these points are known as the high influence. So we operationalize the influence of these terms, which is known as the Cook's distance. So now, do you know what is a Cook's distance? So Cook's distance is a distance which is measured using both the proper like outlier value and the high leverage point. And this Cook's distance is also known as the highly influential point. So this does this. So this we have done. Category prediction, you know that when it is more than 0.5, this is SPSS, no, even in Jamovi. So model fit statistics. So yes, if you see model fit statistics, there is a pseudo R square value. So you will see in Jamovi there are various types of pseudo R square. There is a McFadden pseudo R square. There is a Cox and Snellen pseudo R square, and it tells you about the goodness of fit of model. And then there is something known as the badness of it. See, there is something known as the goodness of it, and there is something known as the badness of it. So badness of it is by the AIC and BIC and the deviance. So AIC is the Akaike information criteria and BIC is the Bayesian information criteria. And why it is called as the badness of it? Because you are aspiring to make a model where this AIC and BIC is less as compared to the initial value. So it doesn't have an absolute value. We will see all these concepts in Jamovi. Don't worry if you don't know these terms. I'm just introducing these terms. I'll repeat these terms time and again. Okay. I think I have told this. I think I have duplicated it.
Not done. Start.
Okay, that this exponent calculator, we will see that. So now let's see in the Jamovi. So this is the question. So I hope you have gone through the article. This was the article for which we have created this dummy data set. So the article was reason for surgery cancellation in a general hospital, a 10-year study. So what they have done, they have taken a 10 years data. Okay, so if you see, they have taken data from an electronic medical record for 10 years, and then they have performed the logistic regression analysis. So if you see, I'm going to the methodology. They have given some definition. What is a cancellation of surgery? What is elective? What is that? Statistical analysis. If you see the statistical analysis, generally they have written a multivariable logistic regression model was used to assess the factors associated with surgery cancellation. Pre-operative diagnosis was included from the analysis due to multicollinearity. So can you see here that they have excluded this variable, pre-operative diagnosis? Why? Because it has got the problem of multicollinearity, which we have just discussed. Additionally, they have identified some important determinants through the stepwise selection function in the model option, and subgroup analysis were performed according to the urgency of surgery.
बहुत अच्छा नहीं दिया.
So in the statistical analysis, it should be a little elaborate, but that's okay. We are not like commenting. We are only seeing that this thing. So this table we will discuss later. Based on this, we have created this data set. First, we'll see the question. So if you see the question, this is again the variation in surgery cancellation rate. Generally, it range from 5 to 20%. I think this is the introduction of the author only. So what is the research question? What are the key factors associated with surgery cancellations? And what is the relationship between these factors and the likelihood of surgery cancellations for all surgeries combined? So they have taken routine surgeries as well as the emergency surgeries. So I have to do what is the activity? I have to conduct a logistic regression analysis to identify significant predictors of surgery cancellation, and I have to determine the risk of patients and hospital related factor on the likelihood of surgery cancellation. So first I will discuss this, the first objective. So this is the data set. We have shared the Excel file also with you. Okay, so how many of, like, how will I count the number? I hope all of you have downloaded Jamovie. Let me close this file. I'll open since beginning. Otherwise, so if we have shared this file with you. So this is the day one. Uh, in the presentation folder, you have this. There is a PPT. There is a data of this binary logistic regression in the Excel form and in the Jamovie this format. So I'm opening Jamovie, the direct file. So yes, can I see the chat? Everyone, okay, nobody has written. So I hope everyone has downloaded Jamovie. If you have not done that, you can do that in the breakout room.
No.
Or you can do it now also. So Jamovie is a software. If I'm just opening, I'm not telling you in this interface only, I'll tell you the basics, little bit of basics, not too much. So that this Jamovie, the interface, the commands which runs in the background is of R. You see that it has got that it has got like variables. These are the if you click on variables, you can see a type of variable. It will appear like this. If you double click on this, it will show you the variable, like type of variable. You can decide whether it is a nominal, ordinal, continuous, or what integer it is. The like this is the levels. Similarly, if you keep on moving like this, it will tell you about the type of variable in your data. This is the data set, and if you like use this arrow, it will be closed. And then again, it will be like this is the option of analysis. So now I'll explain the data set since you have read the article, but still I will explain that. So if you see the variable, I'll start from variable. We have classified this gender as male and female. So one is female and two is male. If you see this age is a continuous variable. Then this is the age group. We have transformed this age group using the option of transform. I will tell you this option, how to transform the continuous, or we have shared the basics of Jamovie video, I think in the group also. You people can see that, and that some basic functions of Jamovie, those of you who are new to Jamovie, you can learn that. And then this is your weight, which is a continuous, and then height. This is the chronic disease. Chronic disease has got 4 levels: no chronic disease, diabetes, hypertension, and both. So there are 4 levels. Again, admission type, we have got OPD admission and IPD admission, 1 for OPD and 2 for IPD. Then this is the department. So there are 4 department: general surgery, OBG, ENT, and ortho. And then anesthesia type, 1 is general anesthesia and 2 is regional anesthesia. Similarly, season, summer and winter. Days of week, it is from Monday to Friday. And surgery type, emergency or planned. And surgery status. So this is my dependent variable, surgery status, done or cancelled. It is a binomial. So cancelled is 1 and the done is 0. So this is the data. So have you understood what all variables we have? So now if you see, there are many options, but currently we will focus on the regression. So if you click on regression, our discussion on these days, these 4-5 days will be largely restricted to this option, logistic regression. We are not going to discuss this. We are not discussing this. This is the linear and the partial. We will only discuss the binomial. We will discuss the multinomial, and we will discuss the ordinal. These 3 we will discuss. And of course, ROC and conditional, which has got other, through some other interface, that we will discuss. So today we will discuss the binomial regression. So what is the, what are all variables are? So right now, I will take all the variables and I'll see which all are there for me as a significance. So the same question which I think Dr. Arun has asked, like which all to take. So that we discussed theoretically. Now we'll see which all variable we have to take in the final model. So you have to click this, you have to go to this regression, click on this. Okay, so first I have to calculate the BMI. So one exercise we have just kept to show you how to convert or compute. So I think weight and height, it is here, weight and height. So I'll calculate this BMI. So how to do that? There is an option of compute variable. So if you go to the data, there's an option of compute variable. So you can write here as BMI and you can write as a function. So what variable I will choose? So I'll choose weight in kg. And then I have to divide it by the height in meter square. So I will take this height, again multiplied by height. I'm selecting from this option. And then I have to multiply it with 0.001 because this will be like, and then I will close the bracket. Why I have? Because it is in centimeter. So to convert it into meter, I have to do that. And then I will press enter. So you will see that this is the BMI. And it is here with a uh, dot, black dot. So if you see a dot like this or a dot like this, then either this is a converted variable or a transformed variable. Because in other variable, you will not see these dots. So this is the BMI. Now we will have to see. So I will come to this. If you open this logistic regression. So let me analyze. If you open this, how to do that? I will just delete this and I will start from afresh. So I'll go to analyze, open this regression, open this binomial. So once you open this binomial, this interface appears. So here you will find that there is a dependent variable. So this is the box of dependent variable. This is the box of covariate. Covariate means you can see that there is a scale here. Here you have to enter all continuous variable. And then there is a box of this factor. Factor means you can see this sign wherever you see, it is categorical. So factor means like all the categorical variable you have to enter here. Covariate means it is the continuous variable or the scale variable. You can see this by the sign. And in this category, you have to enter the dependent variable. So what is my dependent variable? So my dependent variable is surgery status. So this is the surgery status. That means surgery cancelled or not cancelled. And then I will enter. So here we have to see one by one. So in case of now I have to see which all variable will I take. So I am going for a single predictor variable. So how will I take? First I'll enter A, gender. So gender I will enter here. And you have to see the odds. How will you see that? So you have to come down. There is something known as the model coefficient. Right now you only click the odds ratio and you see its significance, p-value. It will be there. So if you enter, you can see that value of this p is, it is significant. Gender is significant. So even if I don't enter this, this is not giving me this. Let me see. Yeah, it's after this. Assumption, no. Odds ratio. So this gender, just a sec. Yes, there was no. So you can see it will give you actually I deleted this block, that's why it was not coming. So you can see the value. So the p value is less than 001. So this is unadjusted odds. It is significant. So that's why I will take this. So now I will take another variable, which is the age. So age I have to enter here as a covariate. So age, if you see the p-value, it is the 0.08. So again, it is up till 0.2. So we can take that. Again, we can take BMI. If you enter BMI, it gives you a p-value. So p-value is 0.7. So it is more than 0.2. That's why we will not take it in the final model. So this way you have to calculate the unadjusted. So after that, you see each and every. Let me do it once again. Just a sec. Analysis, remove. I'll again go to regression, binomial, dependent. I will move the surgery status here. The covariate. First is my gender. So gender in the factor. And I will see the p-value. So I'm only right now, I'm not clicking on the odds ratio because I'm only concerned with p-value. So I'm writing all these variables. So gender is important for me. I've kept this gender. Then again, I will take the age. Age is again, you see the p-value. So p-value is 0.08. So gender, I will take p-value. This also I will take age. So I'm doing the unadjusted odds and I'm seeing the p-value. That's why I am BMI was not significant. I'm not taking BMI. Then I'm moving this chronic disease. If you see the chronic disease, the p-value, if you see here, it has again, everything is not significant. So I'm not taking this chronic disease. So till now only gender and age. So I will not take that into in this model. If I take admission type, then you see the p-value. The p-value of admission type is 0.001. So I will take the admission type. Admission type. So these three variable, and then I will see the anesthesia type. Department, if I see where the cancellation is more or not. So there were 4 departments. So you see that p-value is not like all the p-values are more than, okay, here. It is the, yes, I can take this because in 2 of the variable, it is less than 0.2. So I can take this, it is plus minus, but I will take department type. Then comes your anesthesia type. So if you see the anesthesia, then it is the p-value is less than. So anesthesia type I will take. And then days of week. Days of week, if I have to take, this is again, if you see, it is not significant, only 1, so I will not take this. And then surgery type, if I see the surgery type, whether it is emergency surgery or a planned surgery, and if I see the p-value is 0.04, so I will take the surgery type. So based on univariate analysis, I have got 1, 2, 3, 6 variables. Now, again, we talked about the sample size. So for 6 variable, how many surgery cancellation I should have? Yes, all of you please write. How many outcome I should have if I have to take 6 variable as my predictor variable based on this univariable odds. 90 Akash, Monisha, true. So I'll have to see. So how I'll do that? I'll go to exploration, descriptive, and I'll see the frequency. So this I will move this surgery status here and I'll see the frequency. So if I see the frequency, you will see that cancelled is 91. Cancelled is 91, 18%. So is my sample size enough? At least adequate. We call it as minimum. So minimum of 90 since there were 6 variable. So that's why I can go ahead with my existing sample. Like what would have happened if my cancelled surgery would have been 60? Then what I should have done? Yes, all of you or one of you can unmute and answer. If my cancelled surgery was like 60, what I should have done? Then I cannot take all 6 variable in my model because then there will be bias and my model will not be accurate. And it is known as the data sparsity bias. So that's why I should drop 2 predictor variable and I should do it with only 4 predictor variable. So I will drop out of 6, I will drop 2 and I'll make model only with 4 variables. Am I right? Or am I making any sense to all of you? I don't know.
Ma'am,
Yes.
मैम
Yes.
व्हाट इज मैम इसका रेफरेंस क्या होगा मैम कि अगर एक प्रेडिक्टर वेरिएबल है तो एक प्रेडिक्टर वेरिएबल के पीछे हमें 15 केसेस लेने हैं मैम
इसका there is a reference.
केस नहीं, इवेंट।
इसमें केस नहीं है, टोटल सैंपल नहीं है, इवेंट होना चाहिए इतना।
इवेंट ऑफ इंटरेस्ट।
मतलब जो आपका आउटकम वेरिएबल जैसे हमने बाइनोमियल में 2 में डिवाइड किया है ना, एक इवेंट हुआ और एक इवेंट नहीं हुआ, तो
Yes,
जो
ma'am.
इवेंट हुआ है उतने इवेंट होने चाहिए पर आउटकम वेरिएबल। इसका एक रेफरेंस है, नेम आई थिंक we will share it on WhatsApp. Probably we covered this in our first logistic when we were because first logistic we did with SPSS. So I think that reference is there. We will share in
Ma'am?
the yeah.
मैम जब हम यूनिवेरिएट एनालिसिस कर रहे थे अनएडजस्टेड ओआर को निकालने के लिए, then we found out that there were 6 major predictors as per our as per the result of the significance, ma'am. And ma'am, am I audible?
Yeah, you are audible.
जी मैम। फिर मैम हमने फ्रीक्वेंसी निकाली सर्जरी टाइप की, तो वी फाउंड आउट दैट 90 वर कैंसल्ड। बेस्ड ऑन दैट वी सेट कि हाँ ठीक है, 15 multiplied by 6 is 90, so therefore बिल्कुल adequate था sample size. Is that how मैम the flow went मैम?
Yeah.
तो
You are
मैम
right.
बेसिकली तो इसमें मैम हमने जो नेगेटिव इवेंट था उसको लिया मैम। मतलब अगर जैसे डन वाले केसेस मैम
क्योंकि
इसमें
मैं
जो
नहीं डिपेंड करता है आप क्या, अगर इफ यू आर प्रिडिक्टिंग द सर्जरी डन, okay, Dr. Anuradha is asking repeat the last concept. See, if I am predicting the surgery done, let me show you the article ka title. Reasons for surgery cancellation. The outcome was surgery cancellation. My research question was I wanted to see a model, or I wanted to see the predictors of surgery cancellation. That's why I was focusing on 90. If I am focusing on surgery done, then I'll take the other one.
मैम सैंपल साइज बढ़ जाएगा क्या?
हाँ, फिर आप ज्यादा ले सकते हैं। आप ज्यादा वेरिएबल लिख सकते हैं, आप प्रेडिक्ट, क्योंकि उसका इवेंट ज्यादा होगा। तो वो तो रिसर्च क्वेश्चन पर डिपेंड करता है। दैट डिपेंड्स ऑन द रिसर्च क्वेश्चन, वेदर यू वांट टू प्रिडिक्ट सर्जरी डन और सर्जरी कैंसल।
डिप्रेशन नहीं।
मतलब सॉरी मैम,
Yeah.
मैं आप कुछ बोल रहे हैं मैम।
नहीं, पर फर्स्ट you प्लीज टेल।
मैम तो इसका मतलब कि एक प्रेडिक्टर के पीछे हमें 15 सैंपल्स को उठाना है मैम।
सैंपल नहीं, जो आपका इवेंट आपने डिफाइन किया है, किसको आप यस,
सॉरी
इवेंट ऑफ
जी मैम।
इंटरेस्ट।
तो मतलब एक इवेंट के पीछे मैम 15 उठाना है मैम।
एक प्रेडिक्टर वेरिएबल के लिए कम से कम 15 इवेंट होने चाहिए जो
ओके,
आपने
15
इवेंट
इवेंट।
जिसको डिफाइन किया है.
ओके मैम।
इट
जी
इज
मैम।
नॉट द सैंपल. वाई मेनी पीपल कंफ्यूज कि वो बोलते हैं 15 लोग हो गए तो मतलब टोटल 90 में दे विल पुट लाइक 6 प्रिडिक्टर वेरिएबल. आर यू गेटिंग माई पॉइंट?
जी मैम, तो मतलब कि जैसे इस केस में 90 हमारे सर्जरी केसेस कैंसिल हुए थे 90, हमारे प्रिक्टस 6 थे, मतलब इवेंट जो था वो 90 बार नहीं हुआ। और क्योंकि वो 90 बार नहीं हुआ तो और हमारे 6 प्रिडिक्टर थे, तो हमें 15 मल्टीप्लाइड बाई 6 के लॉजिक के हिसाब से उठाना है, क्योंकि हर प्रिडिक्टर के पीछे 15 हमें उठाना पड़ेगा,
मिनिमम
ताकि हमारा
मिनिमम. लेकिन जरूरी नहीं है. मेनी टाइम पीपल कम टू अस लाइक इन स्पेशली कोविड के समय बहुत सारे मॉडल बने, ठीक है, विद मेनी वेरिएबल्स. सो दे यूज टू कम टू अस कि नहीं नहीं हमें सब लगाना है. सो दैट टाइम यू विल हैव सी दैट यू कैन नॉट टेक ऑल द प्रिडिक्टर. इट डिपेंड्स ऑन द सैंपल साइज ऑल्सो. सो देन यू हैव टू सजेस्ट कि इसमें से कौन कौन आप ले लीजिए जो ज्यादा सिग्निफिकेंट लगे आपको, इंपॉर्टेंस से या फिर पी वैल्यू से.
जी मैम। मैम इस पे और भी कोई तरीका है इसके अलावा, इवेंट्स को देखते हुए और भी कोई तरीका है मैम, जब हमें अपना मिनिमम हमें मतलब उठाना है, हमें सैंपल साइज कितना रखना है?
इसके लिए तो हम लोगों ने रेफरेंस देखा था क्योंकि ये क्वेश्चन आया था बहुत सारे वर्कशॉप में. आता है कि सैंपल साइज का क्राइटेरिया हाउ हाउ शुड बी फुलफिल. सो इन केस ऑफ मॉडलिंग जनरली दैट्स द यू नो द एस्टिमेट बिकॉज कैलकुलेशन तो वी हैव नॉट सीन. कोई
जी
सैंपल
मैम।
साइज फॉर्मूला एंड ऑल आई हैव नॉट एक्चुअली वर्कड ऑन दैट. So
जी
we
मैम।
go by this rule. And that's there
ठीक है।
there are two references for that. I will share
जी
one
मैम।
in Word and the other is one we will share in the WhatsApp group. Currently, I don't.
थैंक यू मैम, थैंक यू।
Okay. And Anuradha is asking to repeat the last concept. So Anuradha, can you help me in defining this last? Last means you want to get these sample size criteria repeated? If I'm correct?
Oh, ma'am, you were talking about some four. I just got my connection lost.
Okay, okay.
So,
Yeah, yeah. Please. About what?
four different permit, like something we were talking about four, ma'am. That
Okay,
four
okay.
and
I said what I said, like in this case, by since this is a created data, so we were having 91 cancelled. If my this event cancelled surgeries total were 60, and I am emphasizing as a clinician to you, no, I want to include all those 6 variables. What will you do or what will you suggest as a data analyst? So then you have to suggest that since the sample size is less, 60 outcome is less for 6 predictors. So you will suggest the clinician that, sir, kindly drop 2 variables and make your model with only 4 variables, because then your model will be good. Otherwise, there will be data sparsity bias. Means your model will be a biased one because data will be sparse. Sparse means it will be less. Okay. So that's why I was talking about this 4, because for 4 variable, I should have a minimum of 60 outcome or event. And here I am defining event as surgery cancellation. Did you get me? Am I making myself clear to all of you?
yes, ma'am.
Okay. So if it is okay, I'll again go to this. So now we know. So I right now I'm taking all these 6 variable. Now how to go about this? So how I will start? So there is a way. There are 2 ways of doing it. One way is entering all these variables at once. So how will I do that? I'll enter gender here, then age in this as a covariate, admission type. I have left BMI and chronic disease because that was not significant. Then department, anesthesia, and surgery type. So 6 variables, 1, 2, 3, 4, 5 and 1 continuous. And then I'll come down. I will first check I have not checked the assumptions till yet. So first I'll check the assumptions. So assumptions, you can see there's a collinearity statistics. Because I have to see whether there is any collinearity or multicollinearity is there or not. So if you see this collinearity, this is the collinearity statistics. So you will see that it gives you the VIF and tolerance. So this is the VIF value. So we will focus on VIF and we say that the VIF should be less than 10. So all these values like gender, age, admission type, you will see that VIF is less than 10. So there is no multicollinearity in my independent variable. So my one assumption is met. Am I making myself clear with this multicollinearity assumption check? We discussed that this multicollinearity can be tested by the VIF. VIF is the variance inflation factor or the tolerance. But we discussed that you should remember only one value because this tolerance is the inverse of VIF. So the value of VIF should be less than 10. So here if you see individual variable, all the variable, it is 1.73, less than 10, 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 and less than 10. All these are less than 10. So I will include all this. Means my assumption is met. Coming to another one. Now coming to model coefficient. Now there is if you see this reference level, here it gives you the reference level. So this is the surgery, this is the odds ratio of surgery done. I mean odds ratio of cancelled. Here you will say done versus cancelled. So my reference level is done. But as Dr. Arun was discussing, if his outcome of interest is surgery done, not cancelled, then you can check, you can make this as a cancelled as a reference. Okay. So it has taken done as a reference means it will tell you the odds of surgery cancelled. Similarly, gender. Someone was talking, I think Dr. Arun, you were only talking about the reference level in that table of postpartum depression, isn't
जी
it?
मैम जी मैम
Yes. So now you can see here that it gives you the reference and you can change also the reference level. So gender, like it will give you the odds in male. And here also, if you see the table, it tells you the reference. So whatever is written later, if you see this, whatever is written later, like female is written later, OPD is written later, this ENT is written later, this general is written later, this is later. So whatever is written later, that is the reference. If you see this emergency, general, ENT, OPD, female, and surgery, this is the outcome. This surgery status is the outcome variable. Okay. So this is the reference value. Now, if you see this is the p value, but you will see that we don't have any odds till now. So yes, before we know, now what is this estimate? What is this estimate? Let's say I will focus only on one for now. 1.04. What is this 1.04? Yes? Anyone? What is
मैम
this estimate?
मैम ये मेल्स में बता रहा है मैम कि मेल्स में ऑड्स कितना है मैम अगर उनकी सर्जरी कैंसिल होने का कंपेयर टू फीमेल्स, क्योंकि फीमेल्स हमने रेफरेंस लिया था तो मेल्स में 1.04 है मैम.
एक्चुअली ये अभी मैंने बताया नहीं, दैट्स व्हाई आई हैव नॉट क्लिक दैट ऑड्स रेशियो. दिस इज नॉट ऑड्स रेशियो, दिस इज एक्चुअली लॉग ऑड्स. दिस 1.40 इज लॉग ऑड्स. रिमेंबर हमने जो बनाया था इक्वेशन, उसमें डिपेंडेंट वेरिएबल में लॉजिट लिया था. ठीक है, ये एक्चुअली लॉजिट है. इसको ऑड्स रेशियो में कन्वर्ट करने के लिए क्या करना होगा? वी हैव टू कैलकुलेट इट्स एक्सपोनेंट. So that's why you will see wherever odds is written, you will see it writes like EXP and then in the bracket this estimate. So all of you now please open, there's a natural log calculator. So this is the calculator.net, and it is the exponent calculator, and you have to use E as a base. So I will open this. You can type natural log calculator, not this one, calculator.net. This one. And here I have to use E.
Okay.
1.01. That was, no. This I always. Here I have to use this.
Base.
Not use as a base.
Use E as base.
Okay. Where is the exponent calculator? Oh, this is the exponent calculator. Sorry. So you click that exponent calculator, and now I have to write here as 1.0. Let me see the value. 1.04. I'm using this 1.04. I will tell you what I'm doing. 1.04. And if I press calculate, you will see the value is 2.05. Okay. Now I will click in this movie. There is a option of odds ratio. So here in this model coefficient, if you click on odds ratio and its confidence interval, this is the estimate. You see, it's the estimate, which is it is giving you log odds. So estimate is, so what is the odds ratio? 2.83. Here you can see here. This is the 2.83. What was the value there? It was not 2.83, na? Let me check. 2.05, 1.04. Okay, yes. Calculate. Yes, so now it is okay. It was 2 actually. So 2.82. Now if you see, it is 2.82.
मैम ये आपने जो 2 डाला था मैम, उसका क्या मतलब होता था उसमें?
वो गलती से वो 2 एज अ बेस था, तभी वो नहीं आ रहा था. I have to.
मैम
Yes.
मैम डिफॉल्ट हमेशा मतलब 1 ही रहेगा मैम?
डिफॉल्ट जैसे मैं बताती हूँ फिर से, जैसे ये तो मैंने जस्ट आई हैव told you for example. Normally if you click that na, that is there. So initially it comes as this. So you have to click on exponent calculator because this is a log calculator. We have to calculate exponent because exponent of that logit is the odds ratio. We convert again that back to odds ratio because how will you interpret the logit function? No, isn't it? It is difficult to interpret. So we calculate this natural log. We again convert this back to the exponent. If you take the exponent of log, again that odds ratio comes. So if you click on that exponent calculator and then click on use E as a base, and there here you have to write like 1.04 and then you press on calculate. So your value will come like 2.82, which you can see here. That this is the estimate, which is the log odds. And I have taken exponent of that. That's why you will see in SPSS and all, they write EXP and in bracket it is written B. So basically it has taken the exponent of this log odds. And so that's why it gives you the odds ratio. Now, one of you can do the same for this age, admission type. Do it for admission type. Or maybe let me see. Yes, you can do for admission type. Minus 3.09. minus sign tells what the minus sign tells? Increase or decrease. Okay. Like in case of gender, it tells like if it is positive, it tells that in male it is more than in females. If it is IPD minus, then it will tell you that it is less because you can see here odds ratio is less than 1. So all of you please calculate. You can calculate the same 1.04 also as an exponent. And then you can see. So all these, if you take calculate the exponent taking the E base, all these estimate, this will be the same as this odds ratio. Because
Ma'am,
after this log odds, we convert this back into the odds ratio. We don't have to do it. The software does it. You only have to click this odds ratio. But I'm just telling you from the concept which we have learned how the software does it. Yes, Dr. Arun?
ma'am, so interpretation of this would be that the odds of males.
I'm coming to the interpretation. I'm
Sorry,
coming.
ma'am.
No issues. I'm just telling you. Uh, I have not again told you again a lot of model fit statistics and all. Once I check everything, that everything is correct, the significance and all, then I will come to interpretation. That comes the last. Okay. So
Ma'am,
that's why. Yeah, please, Dr.
uh,
Anuradha.
ma'am, could you please tell me where you selected that calculator from
Yes,
this page?
I have gone to Google.
Oh, it's from Google, ma'am. Okay, and not in that Jamovia.
No. See, just to tell you people,
Yeah.
this was the Google.
Okay, ma'am, understood.
On Google, if you
सकते हैं उससे भी कर सकते हैं इमेज पे main category.
So this was the okay. Dr. Shamshad is asking me to do it from the other calculator. Okay,
सबसे जो पहला खुला था,
this one.
ऊपर ऊपर ये basically ये 1.04 टाइप कर दीजिए.
So here, if you type 1.04 n is equal to this will also come the first option. Okay. If you write like natural lag calculator, this also comes here. You have to select this E. It also comes from here or there, wherever you feel. Okay, good. I think this is a better option rather than going to clicking and all that. So like maths people, they will laugh at us because my son is like doing engineering, and when he sees me doing this exponent over calculator and all, he was laughing like anything. Like, you guys even don't know I can do it in minutes. And you have to use calculator. So that's the difference between like us and like people who are a mathematician, but that's fair enough. That's why the advent of these software, so that at least we can do it and we can interpret it. So I will come to the interpretation later. So this we have done. Now coming to these are the model fit statistics. So we were discussing this fit measure, isn't it? The deviance. Sorry. This deviance. This is the goodness of it and badness of it. This is AIC. This is BIC. This is overall model test. And this was the pseudo R square, which we discussed for the linearity assumption also we see. So best is McFadden R square. So that's why there are many type of R square, but you can choose to report this McFadden R square. And these are known as the pseudo R square. Why it is not known as? Because these R square, the calculation is based on the probability, which is not exact. That's why it is known as the pseudo R square. So if you see the values, we have not discussed the values. So this is the same. The deviance is 409, AIC is 427, and this McFadden R square is 14%. So this AIC and BIC, the actual value doesn't tell you anything. You have to see the difference from the baseline. That we will see. I have not told you that because I have entered all the variable at once. We have not gone stepwise. I have not made 5 models. So that's why it will give you only one value. And then you have to click on this overall model test. This is important. So if you click on overall model test, you will see that this appears, this p-value. So this p-value, if it is significant, you can say that your model is, this linearity assumption is met, and this model is also, there is a model fit measure is good. This deviance, AIC and BIC, I'll tell you in a stepwise regression. Just wait for some time. I have to show many things. That's why I'm going very, and then you can click on this likelihood ratios test also. So likelihood ratio tests also tells you regarding the predictor. So it tells you regarding which all are predictors which are important. So if you see the the p-values in this likelihood ratios test and the p-value here in the this surgery status. So this is interpretation. I mean, the value, you will find that there's a little difference in the value. Here in the likelihood ratios test, the value is less as compared to here. Like with age, you can see p-value is 0.01. Here it is again 0.1, same is there. For age, it is 0.05. Sorry, it is 0.07. This was for intercept. This 0.37, here it is 0.35. So interpretation is same. If you click on this omnibus likelihood ratios test, it also tells you like value, significance value of these predictor variable. This is almost same here. The calculation is different. It calculates based on the wall statistics, this model coefficient, and it calculates based on the likelihood ratios test. So you may not report this. You can give this table. So I'm unchecking this. So now coming to the another this thing, I wanted to show you the predicted probability. So if you come to this save, I have still not come to the interpretation. So there are few things which I want to tell you. So if you click on this Cook's distance, so overall Cook's distance, if you see, it doesn't give you the overall Cook's distance. So it gives you the individual Cook's distance and then the predicted values. So if you click that, you can go to the data and you can see that there are two variables which has appeared here at the last. It will take some time. I think Cook's distance. Cook's test, I think I don't know why it is not giving the Cook's distance. I'll see. Value it is not giving. I'll see it to later. First, we'll focus on this surgery type. What is this?
Click here, go to see.
No, yes, I have clicked that. It is not giving.
Residual culprit.
Residual. Yes, since I have not clicked on residual. So yes, now it will give. Because this Cook's distance is calculated based on the. No, but residual also it is.
नहीं तो run नहीं हो रहा अभी तक.
Hoga, it is. So it is giving residual. I don't know, something has happened. I'll again do this. And currently, we will see this predicted value. So this column is the predicted probability. So what is the predicted probability? This is 0.965. Can you see this 0.965? So this 0.965, what is the probability based whether the surgery will be cancelled or not cancelled? Yes, we have learned regarding the probability. If it is more than 0.5, then we will call it as a cancelled. 0.5 or more than 0.5. If the probability is less than 0.5, we will call it as a not cancelled. So, is this prediction okay? Actually, based on this probability, the surgery should have been cancelled. And this is the actual status. This is also cancelled. So yes, this prediction is accurate or inaccurate. Yes, all of you please write. Accurate or inaccurate? Okay, SV is writing for admission type exponent does not give odds ratio. Accurate odds ratio. Okay. Okay, we'll see that later, SV, why it is not giving. Okay, but if you take this, let's say this is again done and the probability is 0.169. Is it okay? Yes, because it is less than 0.5. You have to see whether there is a mismatch. So you can see it is again all okay. So I'll go down probably. This is the data. So cancelled. So yes, now you see this variable. This is cancelled, but the probability is 0.482. Is this accurate? This is again cancelled, but the probability is 0.452. Is it accurate? No, it is not. Yes, Dr. Selvaraju is saying there's a 8 mismatched. So you can similarly see, yes, you can see it that what was the difference between the predicted and the actual, means what was the mismatch or percentage accuracy. So this was regarding the mismatch. Let me see why this Cook's distance is not giving, or maybe I'll see what was the problem. Because it gives the Cook's distance also, but currently it is not giving.
अभी run कर रहा है वो.
Oh.
अब आएगा.
Right now, so see, many times that Jamovi like keeps on buffering and many times it gets delayed. So you can see the Cook's distance and you can see like any value, whether the value of Cook's distance is more than 1. So if you inspect, none of the value is more than 1. So that's how you can see.
मैम इसको थोड़ा बताएंगे मोर देन वन नहीं होने से इसका क्या मतलब है?
Agar if it is more than 1, then you have to remove that outlier. And you have to make, you have to see like after deleting that or after removing that, what impact does your model have? Like after removing that Cook's distance. Cook's distance is influential point. That means that data has got a, it is a highly influenced, it has got a high leverage value and it has got a high this thing. That means again, these values will show that that will affect the accuracy of your model. Because this is one of the assumption that your data should not have a outlier and a data should not have, high leverage point. We have discussed the 3 types of anomalous data, remember? We have discussed the outlier, we have discussed the high leverage point, and we have discussed the Cook's distance, which is a distance, which is a operationalization of this high leverage point and outlier. So the value should be less than 1. So all the, yeah?
जो ये this outlier, ma'am, this would be part of it can be part of any of the predictors, ma'am.
No, it calculates overall. It calculates overall because it is calculated based on the residual. So residual, whatever you have seen, residual is calculated overall. It is not calculated predictor wise. Okay, because overall probability is calculated, na. So how it can calculate a variable wise. Variable wise, it cannot calculate. That's why you are making this prediction, na. So overall, this thing it doesn't calculate, and this residual, how it is calculated? See, this is your predicted. This is your 0.965, and this is your residual 1.036. So generally, this Cook's distance, it is calculated based on this residual. Okay.
मैम जैसे एसपीएसएस में आर स्क्वायर की वैल्यू आती है तो उसमें हम बता देते हैं कि इसकी वेरिएबिलिटी मॉडल की कितनी एक्सप्लेन कर रहा है मैम, वो कितने परसेंटेज एक्सप्लेन कर रहा है मैम. तो
लेकिन
इसमें
इस
भी
केस में हम नहीं बता सकते हैं ऐसे. दैट्स व्हाई आई सेड दिस इज नॉट द आर स्क्वायर लाइक यू से दैट इतना वेरिएंस इज एक्सप्लेन्ड. इफ इट इज 14%, you cannot say that 14% of variance in your dependent variable is explained by all predictor variable. Generally, we say that yes, that's why they are the pseudo R square, and we call it there's an improvement. So you just see the improvement from the initial R square. If there is an improvement, and then how much improvement? At least 5% improvement should be there. So those are some minor points. We will come to all those points, but have you understood this mismatch and all up till this point?
मैम ये जो प्रेडिक्टेड था मैम
Mm-hmm.
एंड उसके साथ रेजिडुअल्स आए थे, तो प्रेडिक्टेड तो आपने समझा दिया कि उसकी 0.5 से ज्यादा है तो इवेंट हुआ है, वो समझ आ गया मैम। बट ये जो रेजिडुअल आ रहा है उसके साथ 1.036, मैम नोट स्टडी इसको कैसे अंडरस्टैंड करेंगे?
कौन किसको कैसे अंडरस्टैंड करेंगे?
मैम देखिए, जैसे सीरियल नंबर 1 प्रेडिक्टेड 0.965, वो 0.5 से ज्यादा है। हमने उसको कोरिलेट किया कि सर्जरी कैंसिल हुई थी कि नहीं हुई थी, तो कैंसिल हुई थी सर्जरी, इसका मतलब कि हमारा ठीक बैठा है वो। लेकिन जो रेजिडुअल है मैम वो 1.036 है मैम। तो
Oh,
मैम
so
इसको
your question is ये कैसे आया है?
नहीं, ये मतलब इसको 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 हाउ विल वी अंडरस्टैंड दिस मैम?
इसका मिसमैच कितना प्रोबेबिलिटी, सिंस ये है कि प्रेडिक्टेड प्रोबेबिलिटी तो हमको पता है, लेकिन इसकी प्रोबेबिलिटी के बेसिस पे ये इन दोनों का डिडक्ट करके ये निकालता है रेसिड्यूअल, बट हाउ इट डज लाइक मैथमेटिकली, दैट आई डोंट हैव एनी आइडिया।
तो
मतलब
बेसिकली मैम
बेसिकली यू वांट टू आस्क लाइक हाउ दिस वैल्यू हैज कम 1.03, राइट?
नहीं मैम मेरा नहीं मैम, बस सिंपल ये पूछना था कि ये जैसे आर स्क्वायर की वैल्यू हमारी हमें बताती है वेरिएंस कितना था, वेरिएंस कितना एक्सप्लेन कर रहा है? हाँ,
जैसे यहाँ आर स्क्वायर, लेट्स से इट इज आर स्क्वायर इज 14,
जी मैम,
1.114%.
जी मैम।
So so yes, you continue. You were saying something.
यस मैम, सो मैम व्हाट आई वाज आस्किंग वाज कि ये जो मैथमेटिकल जो डिराइव किया ये वैल्यू, ये मतलब शुड वी जस्ट लीव इट असाइड एंड जस्ट पे अटेंशन टू प्रेडिक्टेड एंड कुक्स डिस्टेंस? अगर कुक 1 से ज्यादा है तो वो आउटलायर है और प्रेडिक्टेड प्रोबेबिलिटी दिखा रहा है, एंड वी कैन जस्ट इग्नोर इट मैम कि ठीक है,
Is
दिस इज जस्ट अ।
residue? Oh.
नहीं, ये रेसिड्यू कैसे कैलकुलेट, इस पर ये रॉ रेसिड्यू नहीं है।
No, 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 no.
This is not raw.
You are saying two concepts here. At one point of time, like what I got, you are saying R square 14%, and then you are saying residual. So actually, I'm not able to comprehend where is the confusion. So can you please elaborate a little bit more?
Ma'am, what I'm trying to ask is, when you were explaining the concept, you showed us that, for example, serial number 1, ma'am, देखिए ma'am, the predicted
Okay,
was 0.965,
ठीक है.
and then ma'am, then it was told that since it is probability is more than 0.5, and
Hmm.
here the computed value is 0.965, and then if we see, actually it is right because the surgery was indeed cancelled.
यस, सो ये जो प्रेडिक्टेड प्रोबेबिलिटी है ये कैसे कैलकुलेट हुई है? ये हमने बताया था मैक्सिमम लाइक्लीहुड टेक्निक से कैलकुलेट हुई है, ठीक है? ये
Yes, ma'am.
क्लियर हो गया? अब आगे
Yes.
बताइए.
आगे मैम फिर हमने रेजिडुअल पे क्लिक किया तो ये रेजिडुअल्स की वैल्यू आ गई मैम।
हाँ, ये रेसिड्यूअल स्टूडेंटाइज्ड रेसिड्यूअल है.
एक के अंदर नहीं।
स्टूडेंटाइज्ड रेसिड्यूअल, रिमेंबर हम लोगों ने बात किया था कि जिसमें आपने उसको जो एरर ऑफ रेसिड्यूअल है उससे डिवाइड कर दिया था. दैट्स हाउ इट गेट्स कैलकुलेटेड. सो रेसिड्यूअल से अभी क्या है, मतलब आई डिडंट गेट हाउ दिस रेसिड्यूअल इज मेकिंग कंफ्यूजन.
He is making 1 minus predicted probability residual.
Okay, are you doing like 1 minus this predicted probability as residual? Are you telling
मैम
that?
That is wrong.
नहीं
No, no, he's not saying that. Like
मैम, मैम I'll ask in the group, मैम I'll ask in the group, I'm not able to vocalize it मैम, मतलब let me internalize it मैम, I'll get back on the
okay,
group.
okay, no worry. But ये जो residual है ना, ये this is studentized residual. This is not the residual, that raw one. Okay. Then coming to, so have you understood the mismatch between the surgery actual predicted and the surgery done? So, and we have seen the Cook's distance also. So since all the we have seen the value, and we have now comes the, and we have seen the model fit statistics, and then assumption check we have done, and we have seen the reference. Again, now we will come to interpretation. So this is the interpretation. Now you were saying, Dr. Arun or anybody else, so no, before I move, yes, anybody who is not able to understand up till this point, because then I will go to the interpretation. Barring that, there was some ambiguity related to residual. Barring that, is everything else clear? That's reference level, then your collinearity statistics, your model fit statistics, your R square, and your likelihood ratio test, odds ratio, confidence interval. Yes, Dr. SV has written that like something was not coming na. What can
उससे नहीं हो रहा है, उससे दिक्कत हो रहा है उसका कुछ, जैसे ई बेस पे -3.09 नहीं आ रहा है, वो दिक्कत हो रहा है उसमें। पॉजिटिव साइड तो आ रहा है, नेगेटिव साइड आने में दिक्कत हो रहा है, शायद लगाना नहीं
so
था
maybe
उसको।
some calculator we are not using is it appropriately. So I will see how, but
उस
that
पे
is the way. Maybe with the minus we will see once again how to do that.
उससे आता है ई बेस।
E-base रुको तो
Net से
let me
आता
see रुको.
Ma'am, uh,
Yes,
ma'am,
please.
yes. Ma'am, pseudo R square, which one to take? Like you selected the first one now, but where is every time we have to select the same pseudo R square?
McFadden. Generally we select this McFadden. These all three, Cox and Snell and Nagelkar and Jude's R square we don't report. If you see, they say that McFadden is the best to report.
Like, because in SPSS we used to do that Nagelkars and
Yes,
options.
but no, now even in SPSS, I don't know, but we have seen, and there was a paper also, I think that was written by McFadden only. He has said that, I mean, it's better to report McFadden.
Okay.
Yes, you are right. We used to report Nagalkar.
वो भी चलेगा, कॉक्स
That is also good. Okay, but you should not report Cox and Snell. Either you report McFadden or you can report Nagalkar.
What's the criteria?
Pardon? You were saying something? Actually, this McFadden is a little conservative. If you see the difference, Nagalkar is saying 20%, whether McFadden is saying 14%.
Ma'am,
You can
ma'am, the 4 R squares were given in this, no? So
yes,
how
I
to
will.
select, based on what? Yeah.
I will come to that. I'll come. Let me first clear that exponent wala na value. Which value is not coming? Minus 3.09. So if I go here
-3.0
and I write minus 3.09.
उस वो वाला पर ठीक से नहीं कर पा रहे हैं।
It is 0.04. What is the
0.45.
value?
0.45.
0.45. So it is there. I think this is better way. Dr. SV, can you see? Okay. So that was, I think, initial. So shortcut will not, that was better. This is better way to do that. What we were doing initially, this exponent calculator. So now comes the question of Anuradha. So for that, now I'll have to show you that. So what should I do? First, I tell you the builder. First, let me explain the interpretation one, and then I will go to this model builder. Okay, before that interpretation, let me show then. So this was the model builder. Remember, here we have entered everything in block 1. So how to interpret this? How you do? You add one block. You first enter age. In first block, add a new block, then enter gender. So that way, what will happen? You are making a model stepwise. So one model you have made with only age, then age and gender. Then you can enter this either in new block, admission type, and probably then you can enter, again I will add one new block. Maybe you can enter department and anesthesia type together in one block. No.
Reflection आ जाएगा।
नहीं आएगा, वो नहीं आता जब तक once unless and until you do. Okay, एक मिनट, ठीक है, just a sec. So then you enter, okay, yes. department, anesthesia, or surgery. Okay, then you can see that here I have put this model wise, model comparison. It will take some time, and it gives you a statistics. It is buffering. So initially I have told you everything together in one model, but now you can choose to enter these one by one, and then you can see these model fit statistics. So basically, if you see this numerical R square or this thing, initially it was very less, only 1%, but gradually it has increased to 14%. Similarly, this has also increased to 20%. If you see AIC and BIC, it is again decreasing, 475, 453. It is least in model 5. This is again least, deviance is least in this model 5. And this chi-square value, we want more chi-square value. This is more in the 5th. So based on that, you can see that you go for 5th model. So that's how I was saying that individual value doesn't have a much. We say that the value of this R square should be 0.2 to 0.8. They say that yes, it is a good fit, but it is not the way we used to explain the variance, the linear regression. Like the variance in the dependent variable can be explained by the independent variable. That concept doesn't hold true here, and we only tell like it is a model fit measure, and we say that how fit our model is. So if the value is between 0.2 to 0.8, we see that it is a good model fit statistics. And similarly, you can say like this deviance and AIC and BIC, that model 5 has got the least deviance and AIC and the highest chi-square. So you say that you will go with the 5th type of model. Then from here, you can, this is again shows the model comparison. You can see model 1 is also significant, but 5 is also significant, where it is having the how many predictors, 2 and 3. And this you can see, model 5. If you select from here, it will give you the result of all model. So it gives you the predictor, this thing again. Now you can, from here, you can see these. Again, this will be the same. Here, this is the 5th model, which we have made initially. So now you can interpret. So I can now come to the interpretation. Have you understood up till this point? Then I will come to the interpretation. The relative value of the R square, AIC, BIC, chi-square. Is it okay to everyone?
Ma'am, just a doubt, ma'am.
Yeah.
Ma'am, all this, you have told 5 different models, right, ma'am? Like, what is the difference between each model, ma'am? Like, what all is considered for each of these models?
Okay. So here in block 1, it is only taking in model 1, it is only taking the one predictor variable, that is the age. In gender, it is, if in block 2, I have added gender, like I'll show you. I'll select model 1. You will see what is the difference. So model 1 is only taking age, because in block 1, I have added age. If you select model 2 here, you will say it is taking age and gender. If you select model 3, it will give you age, gender, and admission type. If you select model 4, since in model 4, I have entered 2 variable like one by one in the same block. So it will give you the admission type and department, this thing. You can see here, department. Or in 5, I have added both. So if you select 5, you can select and see here. So the way you have entered these predictors in these blocks, the name of the models are in block 1. But if you enter in block 2 gender, it will take the previous block 1 predictor variable also. Are you getting my point?
Yes, ma'am. Yes,
Venkatesh,
ma'am.
is it clear now?
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Anyone having any other problem up till this point? So I'll just tell one interpretation. Okay, done. Venkatesh is done. Anuradha is done. Okay. So one, like we say odds ratio, let's say gender, it is 2.83. So how to interpret? We say that surgery, odds of surgery cancellation, it is twice in male because my reference is female. It is 2.83 in males as compared to female. Similarly, if odds. Now, if I have to express it in percentage, then how do I do? You have to minus it, minus 1. So, in 283 or 2.83 minus 1, 183. So, you say that there are 183 percentages chance of this surgery cancellation is male as compared to female. But for this thing, for less than 1, generally we express it in percentage. Here, you can express it in terms of odds. So, that's how we write interpretation. Is it clear? Yes, Dr. Arun?
In this case, like when we are using SPSS, we have to notify the reference category. This maybe, ma'am, does Jamovi take it on a default port, or do we also do the same thing here as well?
No, it does. Default means it takes on the basis of this thing, coding. So it takes higher as a reference. You can see it is taking female as a reference. So let me go and check the variable data. If I see, let me see. You can change the reference. That is okay. If I double click the reference, you can see male is 2. So it takes lower category as a reference. Default setting is lower category. Okay.
Okay, ma'am.
If you see the reference, but there is an option here, you can change the reference. Like gender here, if you want in male, if you want in female as compared to male, then you can see 1 by 2.83. So it will come as, you will see that it will change. So it will 0.35.
Right, ma'am.
So that
Actually,
reference
ma'am,
category you can change.
Actually, ma'am, this interface is quite easy compared to SPSS. SPSS is more difficult to learn.
Actually, the problem with SPSS, there is a set of too many tables. And it will come and then again you have to select which all to
Yes, ma'am.
report. And many times it is a little heavy. The other thing is it is not dynamic. Here though, if you
Yes,
change,
ma'am.
the previous one will go. But again, if you want that previous one to be here, then you have to right click it. You have to either you can do like analysis, duplicate. If you duplicate it, the previous one will be there and then you can play with the other one. Or you can copy paste that, copy and paste it, or you can export it. These are the options which you can do. But again, we find this Jamovi, I mean, very easy. Very easy means as compared to other software. So I think it's already 5:15. So breakout room activity today we planned, but we could not do. So we will start with the breakout room activity tomorrow. The data set is there with you. You can practice once at home and we will share the today's recording also. So that those of you who have missed. So tomorrow we will show you the subgroup analysis, the interaction and the multinomial. And I mean, there will be 2 breakout room, one for this, another for multinomial. So, should we call it a day off for today? Okay. So, thank you, everyone. So, we will meet tomorrow at 2.
Thank you, ma'am.
Thank you.
Thank you, ma'am. Thank you so much.
Thank you, ma'am.
Thank
Thank you,
you.
ma'am.